Testing 1 2 3 testing 1 2 3 testing. Testing. I think we're talking about what's bothering us in general. Here goes. We're talking about what's bothering us in general. What's going on in our lives? What's upsetting us? Everybody's upset about something. My friend Locust has got some health problems right now, which is kind of scary. We're all upset about something here. Testing 1 2 3. Sorry about the wait, guys. Yo, what's up? Welcome back to Vencabot. Intro to Python action. My name is David. Here we're learning Python programming as complete beginners to programming. I've been programming for almost 20 years now, self-taught. Python is my favorite language. It's a great language to learn as a total beginner. Before we get started, guys, we're enjoying music in the background very, very softly. My friend Aubdat, that's A-U-B-D-A-T, aubdat.bandcamp.com. Very cool guy, really nice ambient, droning, sort of, kind of a little bit avant-garde kind of music. I find it's good for focusing and studying and that kind of thing, and programming especially. Let me actually do this now. Now we can go back to docs.python.org. We can learn all about Python and stuff. We're going to be using the library reference a little bit tonight, I think. It was up Blake to teach me the ways. Zan says, and time to go to bed because I got me work tomorrow. Good stuff, Zan. Have a good rest, you. Glad you stop by. Have a good sleep, homeboy. Always a pleasure having you. Here goes, says, to who it may concern, you've got my hopes for better tomorrows. Yeah, thank you. Here goes. So whether it be some first world problems or some health problems or whatever, I still, likewise, hope that all goes well for you guys. I think for the most part it will, I hope. So guys, we're looking at our text adventure game. We're making a textual adventure in the style of Zork. If you guys don't know what Zork is, it's a game where you punch in commands into the game. Actually, restart this game right here. If I run F5, will that restart it? It's supposed to be saved. Yeah, that's fine. What? No. I guess let me, how do I kill this? How do I just run the module? There we go, I'm sorry, I have no idea what the hell was happening there. Yeah, so, Zork is like a textual game. Let's just run it right now. So it says you are in a cave, right? It says what you want to do. Well, we can type in help, and it gives us a list of things we can do in the game, such as look around, do a dance, open the chest, get the key, leave the cave, get the torch, open the door, unlock the door, enter the door, etc. So let's look around. Look around. Okay, it says the cave is dank and there's a treasure chest. There's also a door. There's also a torch. Okay, well, we can open the chest. Okay, you've opened the chest. There's a key inside. All right, let's get the key. Okay, cool beans. Let's get the torch that was on the ground. Awesome. So we got the key and the torch. Now we can open the door. Oh, the door is locked, dang it. Okay, well, we got the key, right? Let's unlock the door. Okay, use the key to unlock the door. Awesome. So now we can open the door, right? Okay, now the door is open. Cool, now we can enter the door. Okay, so it's now says you walk through the door. Well, let me look around again now. Okay, so strangely, you find that you're in a comfortable living room. You see an old record player in the corner. You see a staircase to the basement. Okay, so basically, again, if you guys aren't familiar with Zork, the idea is that you read and you write, right? You read some text and you type in some text, like to command your character to do something, and then you do it. And the goal is sort of like a point-and-click game, or like a Zelda game. You kind of have to find items and use those items to advance in the game. It's a very simple game to program and a great way to learn the very basics of programming. So how does this game work? How does it work, right? I mean, really, how does it work? Well, let's go look at our code here, right? So this is in a program called Idle. Idle is a sort of a Python editor. Python is the language we're using to write this code in. And what makes Python different from Notepad really is a couple features. One is that it highlights your code in all kinds of cool colors, which is pretty easy on the eyes. And not only is it attractive, but it's also good for helping you very quickly parse what you're looking at. For instance, the names of functions, as you can see here, are color-coded. Things like strings, that's textual strings, are color-coded. Likewise, little statements like def and if and all these things are color-coded. So it makes it a little bit easier to scroll through very quickly and kind of get a feel for what's going on. This game is, how many lines of code? 175 lines of code. So very short, very, very short little game we've written here. And before we actually get started today and try some new stuff, let me go through how the game works as of right now. Now, first of all, guys, if you guys want to learn Python, you have to do basically one thing, really, and that's download Python. So some languages are compiled languages, which means that you actually write them in Notepad, and you run them through a program to convert them into a .exe file that can run on a Windows computer or whatever kind of platform you want to run it on, right? An executable file. But Python is different. Python is a scripting language. So that means that you download a program called Python, And then what Python does is it reads the code you write and it runs it line by line. Right? So again, a compiler will take your code and spit out a Windows executable file that you can just double click and run. Whereas Python, you write the language and then this program called Python will then run that code for you. So it's kind of cool. It's very easy to download and install. Let's go look at that real quick, guys. If you guys are total beginners, you guys might maybe consider that. Let's go to python.org. Right. I'm sorry, let me go full screen here. So you can go to downloads right here. I'm sorry, I know there's a lot of text on the screen. Downloads, you can get right here for Windows 3.7.1. Looks like I'm already learning. Wow. Yeah, Python 3.7.1. Again, this program right here, its main function is to read the code that you write in Notepad. You just write it in Notepad or whatever you want, whatever program you want to write it in. And then it will execute that code line by line. That's what Python does. It's an interpreter. So what you're writing is a script. It's a scripting language. You're writing a script. And then Python is the interpreter. It interprets that script and makes it run. All you gotta do is download this, no big deal. It's an executable file, just download it, install it, no problem. And so previously, guys, we had been programming using Notepad. And that's perfectly fine. Let's go demonstrate that real quick. All right, here's Notepad. Let's just open our file here. Okay, we're using adventureday4.py. And it's just a text file. There's nothing special about any programming language. Every programming language, with very, very few exceptions, is very simply text. It's just text. And you usually end the file name with a .py for Python, or .cpp for C++, etc. But it's no different than a .txt file. It's just a different name that lets Python know that it's a Python script. And here you can see all of our code here. It's the same exact code we have running in idle, right? So there's no highlighting. So up to this point, we've been using Notepad as a way for me to stress to you guys that there is no special programs needed to run Python, except for Python. There's sort of this stigma among non-programmers. You need to have some kind of crazy software set up to actually program. You don't. You just need Notepad. That's all you need to program, and some knowledge. All right, so here's our script in Notepad, and here's the same script in idle. All the same code, but just color-coded to make it a little bit easier to read. And there are a couple other features idle has as well. Right, now, idle comes with Python. So once you install Python 3.7.1 on that website I showed you guys, if you install Python, it installs this program called idle, which is just a nice little editor. Makes your life a little bit easier. Right? I recommend you try it. It is basically just like Notepad, but it has special features for Python scripts. Again, Notepad is really more for writing just straight-up text files. Right? It can write Python. And for years, I did use Notepad for programming in, for years. But idle is a little bit easier to use. One cool feature of idle is that you can actually just run your script right from here. Right, you run module right there. Whereas with Notepad, you have to use the CMD, the command prompt. But it's whatever, guys. It's whatever. So let's talk about how this program of ours works. Well, first of all, up here at the top of the script, we've got a bunch of lines that are indented, some more than others, right? See how you have like death, look around, all the way on the left side. Then you have this indented here. And then this indented here. And then even more deeply indented right here. In Python and other programming languages, you indent what are called code blocks. So code blocks are kind of like ways to separate your code into pieces that run only under certain circumstances. So basically, if your code is on the far left of the screen, it will always run because any programming language, when it's first read, is read from top to bottom. Right? So here's what's happening in our code, guys. We can actually follow along top to bottom. Here we're defining a function. And a function is just like a little bit of code that can do something. So we're defining look around. And then the next thing it does is it defines do a dance. So even though we're reading from top to bottom, this does not get read because it's indented. Right? Indented code in a code block will only be read through under certain circumstances. So here we're defining a look around function. Then we're defining do a dance. And we're defining a bunch of other functions here. A bunch of function definitions here going down the left side. That's the first thing to happen in our script because it's being read from top to bottom, except for the indented code, which is not being read right away. Now, that all gets defined. Right? All these functions are getting defined. These are just ways, these are things you can do in the game. You can get the record, you can descend the staircase. These are all things you can do in the game. We've named them ourselves, things that are easy for us to read. We could name these anything we want. We could name them, whatever the fuck, right? We just name this function whatever the fuck. It's totally up to us because we're being creative, right? Right? We're programmers now. We can program things, whatever the program, wants it to be called, right? We can call this whatever, but we're calling it whatever this was. Holy shit, I forgot what it was. Let's just undo. We're calling it whatever we want because, oh shit, let me Control Z through this. We're calling it something easier for us to remember, right? Oh, is this get the torch? Might be get the torch. Oh, that was descend the staircase. Okay, let me redo there. Okay, cool. So that was descend the staircase. Anyway, I'm sorry, guys. Got distracted. Here's all of our functions. We're defining a bunch of functions here. And then only at the bottom do we get into the meat of our game. And the actual meat of the game is very simple. Right? So here's our data. So I mentioned before, guys, that when you're writing a program, every program consists of two things. Data and operations. Right? And data is like things that your program needs to know in order to run correctly. Right? Such as, let's say we're making like a shooting game, right? You have to know how much ammo is in the gun. Right? Where are the players? Right? What map are you on? These are all bits of data the game has to know in order to run correctly. Right? Whereas an operation is things that you do with that data, such as shooting the gun. Right? That will actually reduce your ammo count and it will deal damage, that kind of thing. Such as moving the character. Right? Such as changing the stage. So those would be operations. You have data, and then you have operations. How are we going to use that data? Right? In this case, we're actually defining a bunch of data. There are no operations here, strictly speaking. Or I shouldn't say strictly, I should say there are basically no operations going on here. What's up, Bones? Happy Friday. I'm so excited, guys. It's going to be some Super Mario 64 tonight. I'm so excited. Anyway, so the first thing we're doing here is we're defining this dictionary called GameState. Now, Python and other programming languages, of course, have many kinds of data. And some very basic kinds would be like numbers. Right? Like you can have like a number, you could do like, you know, x equals 1, y equals 2, you know, x plus y, that would come out as 3. Right? So that would be a case of some data, 1 and 2, and an operation plus. Then it comes out with more data, which is 3. Another simple data type would be a string, which is a text. These are strings here. You can tell a string because it has quotation marks around it. Right, so we have some basic text here. Look around. Open the chest. There's some data types, right? These are called strings, they're just text. So we have numbers, we have strings, but also we have some more interesting data types that are really kind of exclusive to programming, right? Such as a dictionary. These dictionaries here are surrounded by curly brackets. And what a dictionary does is it will map one piece of data to another piece of data. So in this case, we are mapping the string, chest is open, to the Boolean data, false. So a Boolean is another kind of data. It's like a number and a string. You have Booleans as well. It's a data type. And Booleans are either true or false. Right? So again, we have, how many data types do we know now? We know about numbers. We know about strings. We know about Booleans, that are always true or false. And we know about dictionaries, where you map one kind of data, in this case a string, mapping that to this Boolean. So chest is open is false in this dictionary. Door is unlocked is false in this dictionary. Door is open is false. The player inventory is a different kind of data right here. We don't know what that is yet. We'll talk about that in a second. Adventure is ongoing, and it's a string. We're mapping that to true. There's another Boolean, right? So there's only two kinds of Booleans in the world. There's false and there's true. And the player position is mapped to another string, the cave entrance. Okay, and again, this game state variable here is a dictionary that contains all this data. It contains all these things mapped to other things. Likewise, we have another dictionary here, the cave entrance command map, and the dark room command map is also a dictionary, and the basement command map, and the position map. Right, so a map is another word for a dictionary, by the way, guys. So when you see this map, it's almost always going to be a dictionary. Because you're mapping one kind of data to another kind of data. So we define a bunch of data here. We're going to explain this a little bit more in depth in a second here. We define all of our data, then we go down to the actual meat of the program, where it's actually running. This is where all the operations happen. It looks very simple, right? First thing you do is you use this print function. And when you run a function in Python, what you do is you put the name of the function out there, which is print, is built into Python. And then you put some parentheses after it. So you can call print like this too. So this will run print. So print is the name of the function, right? Print is the function itself. And then you run it by putting parentheses after it. That will print off a blank line onto your screen. Right, so it's not like printing like paper. It prints off onto your screen. That's true of any programming language. It's kind of like a common name for a function. Print will actually put data on your screen. Now, what you put between these parentheses is called the argument of the function. Right, and the argument of the function is the data that it needs to operate correctly. So if you print with no argument, it prints off a blank line. But you can also put in a string there, and it'll put that string on the screen. So here we are calling the print function, right? You can tell by the parentheses that we're calling it. And then between those parentheses, you give it an argument. In this case, you're giving it a string to print off for us. You are in a cave. I know I'm talking kind of fast, 'cause I'm going to review this before I actually get started here. And now we have, as I continue reading down, we have this block right here. We talked before about code blocks, right? About these functions up here. All these indentations, right? A code block always starts with a line that ends in a colon. See this colon right here? So if you see a colon and then an indentation, that means that's a code block. This would be a function definition code block. Right? This all belongs to that. And then here you have another code block, right? Because it's even deeper indented. All right, see that indentation right there? Here's the line that ends with the colon right there. If game state player position equals cave entrance, so if the player's at the cave entrance, then do this stuff. So you can have blocks within blocks, right? This block, this if block, is inside this function definition block. And that's why it's indented even deeper. Because we have blocks within blocks within blocks sometimes. Right? So down here, where our game is actually running, we defined our functions, we defined our data we're going to use. And now we have this while block. Okay? This all belongs to the while block. See how it's all indented by 4 spaces? Right? All this data belongs to the while block until it's not indented anymore. So it says while game state, adventure is ongoing. Okay, what does that mean? So while game state, adventure is ongoing, colon, then here's the block. Well, what a while block does is it will continually loop over that code. It will loop over it over and over and over again until this statement is equivalent to the Boolean value false. Right? Once this statement is false, then it'll stop looping. We can get down here to game over. Because it's outside of the loop. Until this is false. As long as it's true, I should say. As long as this is true, this will keep going over and over and over again. It'll go to the bottom, and then go right back to the top and question it again. Is adventure still ongoing? If so, then do it again. Then jump back to the top. Is adventure still ongoing? All right, then do it again. So what is this? Game state, adventure is ongoing. Well, we have this data up here called game state, right? Right here, game state. Game state equals, all right, so it's a dictionary. Now, when you have a dictionary, you can put its name down, game state, and then you put square brackets. Right? Game state followed by square bracket. We talked before about how if you have a function name followed by parentheses, then you call that function, right? Well, if you have a dictionary name followed by square brackets, what you're saying is, I want some data out of this dictionary. I'm going to give you one piece of data, and you give me the data that it's mapped to. Right? So we give it adventure is ongoing as the key, it's called. Right? We talked about this is an argument to a function. This is the key to the dictionary. This data here, adventure is ongoing. So let's go look at our dictionary again. All right, here's game state, right? And here's the key, adventure is ongoing. And what is it mapped to? It's mapped to true, right? So what we're saying here really is, as long as this value inside of game state is true, keep on looping. So as long as the adventure is ongoing, keep on looping. Right? First thing it says what you want to do. So here we're calling another function. We're only using 2 built-in functions in Python right now, right? We've defined some of our own functions, such as, listen to the record and ascend the staircase. But also we're using some built-in functions in Python. One is print, that prints off data onto the screen. And the other is input. Now what input does is it will actually ask the player to type in something. And then whatever they type in gets saved. Right? So here we're using input, and we're giving it the argument what you want to do. So input with no argument. Right? If I were to go like this and just cut it, right? Get rid of that. This will just simply, give the player a blank line to type on. Right? But if you give it an argument, it actually can give it a prompt. So it actually gives it some text to tell the player what you want. Here we're saying what you want to do, as our argument. That's our prompt for input. And every function, could potentially take some an argument. And the point of an argument to a function is to give it some data to use to do its job better. What we're doing here is we're actually saving the output of this function to this variable named player command. We talked before about how every program has data and operations. Well, equals is an operation. This equal sign here, and what that's called, it's called an assignment operator. So it'll assign this data to this name. We see that right here too, right? Position map is our name. We're assigning this data right here to this name. Some call it variables. On Python, the word name gets used a lot, but they're basically variables. So this player command, and it is now being made equivalent to whatever is whatever the player typed in. Right. So functions, we know they take in data through their argument, right? But they can also return data back. It's called a return. And when data returns from a function, you can simply assign it like this. You can assign this data that's returned by input to a name, like player command. Okay, cool. So we got the, whatever they typed in is now saved here as the player command, right? And here we're just doing some aliasing. I'll explain that in a second here. But what's really important here is we compare the player command to the functions we want, right? So whatever they typed in, we want to find out what function to run based on what they type. Right now in our Adventure Day 1 script, it's much simpler. But as we've evolved our program here, we've actually made it smaller. There's less code now, but the code we have is more complex. And that's true of programming in general, right? You start off as a beginner programmer, and you don't really know the little tricks to make your code smaller. So your code might work really well, but it'll be really sprawling and very hard to manage. As your game becomes more complex, your code will balloon from 50 lines to 200 lines to 1,000 lines. Right, and it becomes very difficult then to make changes to it. You want to, let's say, add a feature or make a new character or add a gun or something like that, right? That will suddenly mean editing thousands of lines of code. And you have to scroll through tens of thousands of lines of code to find it, right? Like, where are you going to make the change at? So it's kind of interesting that as you become a stronger programmer, you have to comprehend more complex ideas. But once you know a more complex idea, then you can actually make your code simpler. Right? It's kind of counterintuitive that way, where you would think that simple code would always be the best. You want to do it as simply as possible. But what's simpler to a beginner is not what's simpler to an experienced programmer, because you learn ways that are more elegant, ways that are easier to manage, ways that allow you to make your program better faster. Right? It doesn't take as much time to make a new feature, something like that, right? So in our case, what we're doing here is we are using these command maps we made. These dictionaries we made here. For instance, a cave entrance command map, right? So we took a string that the player might type in, and we mapped it. You get the dictionary, right? We mapped this data. This is the key of the dictionary. We mapped it to the value of the function that we wrote that will run when they type in that command. So do a dance, they might type in, right? We're saying if they type in do a dance, then return, give back this data, do a dance, which is a function name. Let's go back and look at do a dance up here. Right here. So do a dance is a function. We defined it right here. So if you see a line starting with DEF, that means define this function. And we define this function do a dance. It takes one argument, which is the game state. All of our functions take the game state as their argument, the only argument. And all it does here is it prints off a line of text. You perform a breakdance. What style? Should we demonstrate that, guys? Let's run our module. All right, so it says here, you're in a cave, what you want to do? Let's do a dance. Okay, there you go. It says you perform a breakdance. What style? Right, so all it did is we typed in do a dance. Right, we typed in this string. And then down here, it compared that string to the, well, it put the string as a key into this dictionary right here. The cave entrance command map. So it said, well, what is do a dance supposed to do? Well, it runs this function, do a dance. So then this function up here, do a dance, ran, and it printed off this text on the screen. Right, that's exactly what just happened. Right? We typed in do a dance at the command prompt, and then it used that data as a key and got back the function, and then it ran that function. Now again, before that was a little bit simpler on our day 1 code. We're actually on day 4 of this project. We're actually looking at some more advanced ideas today, but I know we got some total beginners in the chat right now, so I'm kind of going through the very, very basics again. But what we're doing here is basically we are finding out where the player is at using this game state player position. Right, we're giving this game state dictionary the key player position. And if we look at our game state dictionary up here, you can see it starts off at cave entrance. We're getting a command map from that. So we have 3 different rooms in our game. We have the cave entrance, the dark room, and the basement right now in our game. You know, it's 3 different rooms. And each room, you can do different things, right? The cave entrance has a treasure chest, for instance. The dark room has a turntable, like a record player. And the basement has a shelf with a record on it. So in each room, you can do different things. And so what we've done is we've actually given each room its own list of commands that are then mapped to functions. Right? We have the cave entrance command map. You can do all these things in the cave entrance. We have the dark room command map. These are things you can do in the dark room. Right? And then we have the basement command map. It's very, very small. The basement's a very simple room. All you can do is look around, get the record, and ascend the staircase. Right? So what we're doing is we are taking the player position, and we're finding the command map for that position. So we're saying, hey, listen, the command map is equal to the position map using the current position as the key. Well, here's our position map. Right? So let's say that we're in the cave entrance, right? That means that game state, player position, is equal to cave entrance. Right? So then the command map is the position map, right here, given the key current position, cave entrance. Okay, so we get this cave entrance command map back. Right, let's go look at that. It's right there. So basically, this is a dictionary of dictionaries. Right? The position map is a dictionary that maps the name of your room to the commands you can use in that room. Right? So here we have, you know, if the player command is help, then print off the strings, you know, print off the commands you can do. Right? Like we did that earlier. Otherwise, if it's not help, then say, hey, listen, the command function is the command map given the player command as a key. Right? So again, we found out our command map is this, right, for the cave entrance. So whatever they typed in, use that as the key. So they typed in look around, that means that our command function is look around. If they typed in get the key, then our command function becomes get the key. Right? Kind of interesting. And then we have this little function here. So it's actually a block, right? This is a block. Try and accept. So we try to do that, right? We try and get the command function out, and then run it. But we accept key error. So that means if we type in a key that does not exist in that dictionary, let's say that we type in I don't know, pet the dog, right? There is no dog. There is no pet the dog function. So that if we try that key in the dictionary right here, command map pet the dog as the key, when we go to our command map, it's going to look through that and say, okay, well, you can look around, you can do a dance, but there is no pet the dog key, right? Well, fuck, that means the program has to crash, right? And the program is done. It's fucked. Except that we actually accepted the error. That means that if you use try accept, that means that if you have an error, do not crash. Otherwise, this would crash. But this says don't crash. If we have a key error, instead do this. Print off, you can't do that. So if you try and get a function out of this command map using a key that does not exist, instead of crashing the program, just print off, you can't do that. You can't pet the dog. Right? And then finally, it prints off a blank line, and it goes back to the top, because it's a while loop, right? It goes right back to the top. Because you can see here, this is where the indenting stops. That means that this is the block. A block will go on until the indenting stops. So here we have, for instance, this try block, right? Try and then colon, that indicates a block starting, right? This is the try block right here. We know that because this is where the indenting stops. So the entire try block is indented. Right? Now we have the accept block that follows up the try block. And then here's where this one ends right here, right? That's the only indented line. And then this line here is indented to this level, right? That's 4 spaces in, right? 1, 2, 3, 4. So where does this belong? Well, this belongs in the while block. Right? These all belong in the while block. But this print one is not in any other blocks. You know, it's only in the while block. Whereas this one here, this print statement, is in the accept block, and this else block, and the while block. It's indented by 12. 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4. So in Python, whenever you indent another block level, you add 4 spaces. So as you can see here, we have a while block, which contains an else block, which contains an accept block. So this is actually indented in 12 spaces. This is actually inside the except block and the else block and the while block. This one here is only inside the while block. Okay, so basically the way our game works right now is that it uses a lot of dictionaries. We talked about that last week. So our adventure day 3.py was introducing the idea of dictionaries. And we're using these dictionaries to minimize the amount of long if statements. So basically an if block, let's just say this real quick, guys. We mentioned before, very briefly, that a code block is a code block because unlike regular commands in Python, like print here, or this assignment, right? Unlike these, the data in a while block, or the commands in here, will only run under certain circumstances. That's true of any block. That's how you know a block, right? So here we have these function definitions, right? These are all blocks, but they will only run this code if this function is called, right? It doesn't actually run, you don't just read the script straight from the top to bottom and then run all this code. This code only runs when the function is called. We're defining a function, right? So this code, we can call this code at will. We can make it run anytime we want, but it doesn't run right away. It runs when we call it. And then you have these if blocks, right? If this, you know what I mean? If this, then do this, right? So the if block, I'm going to try and find a really simple one here. Okay, here's a pretty simple one. So what an if block does, it'll only run the indented code, you know, the code in the block, if its statement is true. So we're saying, you know, if torch not in game state player inventory. So if you don't have the torch, then run this code. Otherwise, don't run this code, right? Only run this code if this is true. That's true of any code block. Every code block only runs under a certain condition. Functions only run when they're called. If blocks only run if their condition is true. Else blocks only run if the preceding if is false, right? So if they don't have a torch, then do this. Otherwise, do this. If they do have the torch, then do this, right? If they don't have the torch, do this. If they do have the torch, right? Otherwise, that's what else means. Otherwise, run this code. Here we have an elif block. An elif block is very much it's just an else and an if together. So, you know, if not game state, door is unlocked, right? So if the door is locked, then run this. Elif means otherwise if, right? So otherwise, if not game state, door is open, right? So if the door is closed, right? If not door open, then run this. Otherwise, run this. So elif just means, you know, if the previous if was not true and our statement is true, right? So if this is true, run this. Otherwise, if this is true, then run this. Otherwise, run this. So you have a kind of like it's a very popular kind of block sequence in Python. It would be if, elif, 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 else, right? If this is true, run that. Otherwise, if this is true, run that. Otherwise, if this is true, run that. Otherwise, run this. Looks like block string? Kind of. Kind of. String of blocks. Looks like now you're speaking my language. Okay. So I know I'm talking pretty fast, guys. Again, if you guys want to watch more of this series, go check out my YouTube channel at youtube.com/Vencabot Archive. We have 2 different seasons now. And the way that seasons work for Intro to Python is that we start off with the very basics, like you have never programmed once in your life. And I go through the very basic stuff. Our day 1 script is usually very simple. And then as we go from day to day, we actually introduce new concepts. Here we are on day 4, guys. So we're kind of introducing a lot of new concepts. Some things may be kind of hard to gather, an understanding of if it's really your first day programming. It might be more suited to our day 1 adventure, right? That'd be on YouTube right now. Go watch us kind of start this project. And using only very, very, very basic ideas. Here we are using a lot more block types than we did on day 1. We have a lot of new block types to use. We have some new data types like dictionaries to use and that kind of thing. Back in the day, we only had a very small tool set, and our program was very simple to understand in that respect. However, again, as your program is simple to understand for a beginner, it's very difficult to add on to. to give it new features. In fact, today we're going to be looking at classes finally and object-oriented programming, and we're going to be able to make our game a lot cooler, a lot faster. Right now we've been kind of taking a long time to make it cooler because we're very limited in our tools we can use. But as we have more tools at our disposal, we can actually make our game a lot cooler, a lot faster, with fewer lines of code. So if we tried to do all this stuff with our day one knowledge, it would be like 10 billion lines of code. But today we're going to be doing some really cool stuff with very few lines of code that can make our game a lot more fun. Lucas says, can we get a Vencabot University certificate to hang in our offices? Hell yeah, dude. I should make that. That'd be kind of fun. Okay, so I've discussed the very basics of how this game is working. Right? But let's go into a little more nitty-gritty. For one thing, what we're doing here, let me show you an example of what I'm talking about here. So here we have, where the actual player's command is being executed. These lines right here, that's what, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 lines of code. This is where the actual player's command is being executed. Here's what we're saying. We're saying, hey, listen, if the player command is help, they typed in the word help, then do this stuff here. Print off, you have these commands available to you. Then we're saying, for a command string, in command map.keys, there's, you can see this function name followed by parentheses. We're calling a function there. Then print off 4 blank spaces plus command string. Okay, this line right here, these 2 lines make no fucking sense, right? Because this is actually a feature we introduced into our toolbox last time on day 3. So it's kind of one of the more complex ideas in this entire program. Let me explain what's going on here. We have this new block type. We talked today about function definitions and about while loops and about if statements and about else statements and elif. Right? We talked about all kinds of block types today. We know that a block is when you have a line that ends in a colon and then it's indented, right? This is the actual block right here. This is the first line of the while block. This defines it. This is what we're saying there's a block here. And here is the actual block itself, all indented. Thanks for the follow, Hi-Fi CS. Welcome aboard, dude. We program here every Friday. In January, we're going to be programming almost every day, guys. We're going to be expanding our programming streams here in January. As of right now, though, guys, we're mostly a gameplay stream. We stream gameplay all the time. But on Fridays, we do programming here. In particular, like programming classes. If you have any questions, Hi-Fi, let me know. Okay, so we have these, these blocks. Here's a new block for us. It's a for block. Right? For. There's the colon. And here's the block, just one line. What the fuck is a for block? Well, we talked before about how we have this data type we haven't covered yet. Right here. The player inventory. Right? So we know about, numbers. We know about strings, like chest is open. We know about functions. That's a data type, like right here, for instance. These functions. We're not calling them. There's no we're not calling them with the parentheses, right? We're just giving it the function as a piece of data. Here's the function, right? And then we can call it at will like that, but we're not going to call it yet. We have these functions. We've got Booleans, like false and true, right? We've got dictionaries, which are these things. This entire block here is a dictionary. This entire object is surrounded by these curly brackets. And it's indented here just to make it visually more parsable to understand it. So basically, we could also do this, all on one line if we wanted to. But if we did that, it'd scroll way off the side of the screen. It'd be such a long line, right? So here we're doing what's called a hanging indent in Python. The hanging indent is when you start with this open, like a delimiter, like parentheses here. So this is a curly bracket. Then you break the next line, and you indent it twice. That's how you know it's not a code block. Right? If it was indented once, it'd be a code block. If it had a colon at the end, like this or something, it'd be a code block. But we actually are starting it with a delimiter, such as the curly bracket for a dictionary, or a parentheses for a function call, or these square brackets for a list. And then we're giving it a deeper indent than usual. This would be a double indent. So this is eight spaces. This is it's called a hanging indent in Python, and that means that this indent doesn't really have any meaning insofar as it being a new code block. It's not a new code block. It's just we're just breaking the line there to make it more easy to read. We're breaking this line so it doesn't have to be like one giant line here for this dictionary. So this is not a code block. Right? Again, code blocks are code that only run under certain conditions, and the first line ends in a colon, and it's indented by 4 spaces. Right? This is not a code block. This is a hanging indent. It's just there to make it visually easier to read this dictionary. Anyway, we have all kinds of cool data types, right? But also we have this new data type here, a list. So a list is actually simpler than a dictionary. It's kind of like a dictionary, except that instead of mapping a key to a value, it just has a bunch of values. So there is no key in a dictionary. It's just a bunch of junk you can pile in there. And here we have this player inventory. That makes sense, right? The player inventory would be a list, right? You can put things into that list, such as a key or a torch or a record or whatever, right? Gold, treasure. You can put it all in that inventory. It's just a big list of junk. And what's cool about lists is that you can iterate through them using a for block, right? So what a for block does, it says for each item in this list, do this thing to that item, right? So you can name the item. So for each item, so we're calling it command string in this case, right? For command string in this list, command map.keys. So keys is a method, which means it's just a function. A method is another word for function. It's a method of command map. And what it does, it returns a list, essentially, a list, something iterable, of that dictionary's keys. Right? So let's see, if we have a command map, right? So our command map for the cave entrance is right here. We're saying we're going to run this dictionary's keys method. Right? We're going to run keys on it. And what keys does, it gives us back a list of all the keys. Look around, do a dance, open the chest, get the key, leave the cave. Right? We talked before about how dictionaries have a key and a value. A key and a value. And you can give the dictionary the key and get the value out of it, right? That's why it's called a map, because you're mapping one piece of data to another piece of data. Get the key. What's up, Faust? Do a little dance. Make a little love. Get down tonight. Exactly, Faust. Faust knows. So what we're doing here is we're saying, hey, listen, for every key in command map, right? For every item in this list, we're calling that thing command string, right? For every command string in this list, command map.keys, then print off 4 blank spaces plus the command string. What does that mean exactly? Let's go over here to our game and type in help. What happens? Okay, well, it does what you would expect, right? So it says, you have these commands available to you. So if the player command is equivalent to, and we know that the single equal sign is the assignment operator, right? Single equal sign means we're assigning this data to this name. A double equal signs is a Boolean operator, right? It's a comparison, it's a comparison operator. What it does is it compares 2 kinds of data and gives you back a Boolean. So if player command is equivalent to help, so if this comes out as the Boolean true, right? If the player typed in help, then print off, you have these commands available to you, and then for every item in this list of keys, print off 4 spaces, and then that item in the list. Let's go look at it. Okay, so it prints off 4 blank spaces, followed by the first key, right? Then does it again for the next key. 4 blank spaces, and then the next key. Then it's a loop, right? It loops over every item in this list. That's really the power of a list in Python, is that it gives you something to iterate through. So you can put a bunch of data into this list, and then you can go through each item and do something to it. Right? In this case, we are going through every command in this list of keys, and then printing it off for the user. So this loop only ends once it's out of stuff in the dictionary. What's up, Metal Storm? Python. Who doesn't love Python? One other cool thing about a list. Now, our last season of Intro to Python was Pokemon. And our last season, we actually started from scratch and made a really cool Pokemon battle where you could define your own Pokemon, make your own moves. That's pretty cool. I'm pretty proud of that. We did that in 6 days. From total beginner novices, by day 6, we were actually playing Pokemon that we made ourselves. But in this case, one thing we did not do in Season 1 was use the in statement. Right? One other cool thing about lists is that you can get a Boolean out of them by finding out if something is in that list. right here, for instance. Right? So if you can't leave the cave in this game until you have the key. That's kind of like our game completion thing, right? You have to have the key in order to leave. So it says if key in game state player inventory. So we know that the game state's a dictionary, right? We're giving it this key, player inventory, and we know that that's a list. Right here. Here's our game state. Here's the key, player inventory, and it's a list, an empty list to start off with. It starts off empty. They can get the key later, though. In fact, let's go get the key first. Here it's right here. Get the key. Okay. So here it says, get the key is a function, right? It says, hey, listen, if the game state chest is open is true, right? If chest is open is true, and key not in game state player inventory, then print off you get the key, and then game state player inventory dot append key. This is what our friend KG kind of joked about earlier about Friday night dot append beers, right? So append is a method, it's a function that belongs to every list. Every list has its append function attached to it, and you give it an argument of what you want to put into that list. So the player inventory starts off empty, right? But if they try and get the key and it works, they get the keys successfully, then we add the key to their inventory using this append method. We'll talk about methods here in a minute, a little bit more. Okay, cool. All right, so where's our, I want to leave the cave, right? Where was that at? Right here, leave the cave. So saying, hey, listen, if key in the player's inventory, so if we have this string key in this list, then they can leave the cave. Otherwise, they can't leave the cave. It says, are you forgetting something? Right. Coolio. So basically, to our knowledge right now, lists have really two main functions, right? One is that you can iterate through them. That's sick. That's really useful. And two is that you can get Booleans, such as true or false, by saying, hey, listen, is this data in this list? That's kind of useful, right? If key is in this list, then do this. Otherwise, don't do that, right? If torch not in player inventory, if they don't have the torch, then they can get the torch, right? Otherwise, say you already have the torch. If you already have the torch, what are you trying to get it for? You fucking doofus. Okay, so guys, today we are going to be looking at classes and really focusing on object-oriented programming for the first time. And before we even get started about that, this is a good time to talk about methods. Right. So we talked last time on Adventure Day 3 on the season, our third day of the season, that in Python and pretty much every other programming language, a period, like a dot, that's like an apostrophe S in English. It implies ownership, like David's car, right? Apostrophe S. David dot car. That means the car that belongs to David. Right? That's how you do it in Python and pretty much every programming language out there. A dot means ownership. So we talked before about, we know how functions work, right? You just define a function and you call it. But a method is a special kind of function. A method is a function that belongs to something else. Right? So we have this append method here. It is just a function, just like get the torch is, but it belongs to this list, the player inventory. And every list has it. It's an append method. And what's really cool about a method is that it automatically can work with its owner. So we talked before about how when you have a function, you give it an argument, right? And that argument's what that function needs to operate correctly. So if append was a simple function, we would need to give it two arguments. One would be what we want to append, such as torch, but the other one would be the list, right? The list we want to append to. Because it needs to know both those things to work, right? Well, no, it doesn't, because it's actually a method. It already knows the list it's going to use. It's the one that it belongs to. So actually, it's for one thing, one benefit of methods is that it saves you having to type in a bunch of arguments because it already knows who it belongs to, kind of like my ex-girlfriend used to do. So that's one cool thing about methods. But another cool thing about them is that not only does it know the list it belongs to, but it has access to all the data that list knows. And we have not talked about that data yet. That data is called an attribute. So we have methods, which are just functions that belong to something else. But attributes are just variables, such as game state. But they're not just variables that are just loose in the ether, like game state is here. They're variables that belong to something else. So really what attributes and methods allow us to do is organize our data. It organizes our data. So right now we have a bunch of loose stuff, right? Kind of like my ex-girlfriend used to have. We have the functions that are all just loose, right? And we have these bits of data that are just loose. A bunch of variables here. They're just kind of floating around. They're in the program, but they are not very well organized. They're just kind of around. So now we can make these variables and these functions into attributes and methods of different stuff to organize. I'm going to explain that in a second here. What's up, Bootcamp? How you doing, dude? The best segment of the stream. Intro to Python. Okay, so before we actually implement attributes and methods in our code, let me make a quick example here. Make a new file. A whole new file. A whole new world. A new fantastic point of view. Happy to hear that, Bootcamp. You're allowed to complain, dude. I don't care how chill you are. Everybody's got complaints. It's our American right to have complaints. Let's save this new script as, we're going to call this classes example.py. Alright guys, so before we get into classes, let me make a comment here in our code. We talked last time about how comments in Python are lines that the Python interpreter, right, the thing that's reading our code, will ignore. Python will ignore any lines that start with this number sign or hashtag or pound. Right, that means ignore this line. We can type here where we want. We can type in all kinds of cool stuff. Whatever we want, you know. This ain't Python code. Doesn't matter, since Python won't be reading it. Right? So basically you can use these comments to explain what's going on in your code, not only for other programmers, but for yourself, 2 months from now. You might, write this code, then come back to it weeks later and be like, what the fuck was I thinking when I wrote this code? Well, you can leave comments there to explain it. I'm going to type in some comments here. Yes, Bootcamp, Mars 64, dude. I'm excited. I hope I can beat it in 5 hours. I hope I can beat it. My fastest time is 3.5. So that was many years ago. Back when I was good at that game. So we're going to say, all of our code to date has been mostly functional. In programming, when you talk about functional code, you're talking about code that's flat. Everything belongs to the program, but there is no ownership deeper than that. So let's go look at our functional ass code so far. Right? We have all these functions we defined. Right? All these functions we defined. We have all these variables we defined down here. But they don't belong to anything except for the program. They just all belong to this program. Right? But that can be kind of hard to organize over time. Let's go back to our class example here. In object-oriented programming, code is organized into structures called objects. Right? What's cool about objects is that they own data called attributes, and they own operations called methods. This not only allows you to more easily understand what's going on in your code because it's better organized. But you can also easily expand your code by creating as many objects of one type as you want. You know, allow me to demonstrate. So we're going to demonstrate how classes work here. It's going to be 120 stars bootcamp. Yeah, I think that game is 120 stars max, not 100. You can beat it with 70. We're definitely going to beat it for sure. Once we beat it, we're going to try and get the remaining stars. The remaining 50 after that. Okay, so, you know, previously, right? Previously, we'd have our data laid out something like this. So we'd have, like, you know, let's give make a person, right? We're going to say, you know, person name is David, right? We're going to give, like, you know, person height is, you know, 6, right? 6 feet tall. Then we could say, what else do we know about person, right? How about person location is Michigan? Right, so we know, you know, his name, we know his height, we know where he's at, right? All these things. Then we have this, you know, how about we have like we have this like a person list, right? We'll make another person. We'll make make another person. We'll call this a person 1 name, right? Person 1 name, person 1 height, person 1 location. We also have a person 2 name, right? That would be Derek. Person 2 height. That would be like, you know, 10.1, a very tall guy. And person 2 location. Derek's on the moon, right? Capital M, that means the moon, you know, our moon. Not just any moon. The moon around Earth. You're not that far away. Okay, so we have 2 people now, right? We have this person 1 and we have this person 2. And we have this person list, right? And the person list is going to contain, you know, well, what's it going to contain? Well, it needs to have, I don't know. We don't really have. Here's a problem, right? We don't really have 2 persons, right? We don't really have 2 persons. We just have a bunch of loose variables that we named after person 1 and person 2. But what goes into this list of people? What goes in here? We could put all the data in there, right? We could put in all the data, like person 1 name, person 1 height, etc. But that doesn't really help us with this list idea. So, what if we want to have these people, you know, say their name? For instance, let's just say, you know, how about define a function now? Let's define a function like person say name. We're gonna give it, you know, the person's name, I guess. It's really all you need. We're gonna print off a thing. You know, it's gonna say, well, let's how about we say person say height, right? Let's say person say height. We'll say location. Right? Person say their location. I'm sorry, guys. Person say location. We gotta give them the name and the location as our 2 arguments we need. What's up, Chinchilla? You wanna learn Python, dude? I've been programming Python for about a decade now. I'm kind of trying to teach it here to some newbies who might be interested. I love Python. I love programming, guys. I want to really spread my affection for programming as a creative outlet. I'd love for you guys to become programmers and make your own stuff. It's really, really cool. So when you run this function, person say location, you need to give it 2 things. The person's name and their location. We're going to print off, you know, person name plus a string space says, you know, I'm from, right? Then we're going to add in their location, right? Then put a period and then another one of these and then another one of these. There you go. So basically we're kind of combining a string here. We're combining their name with this string, says, I'm from, space, then adding another string in, their location, that we got right here as an argument, and then we're adding in a period, and then we're going to end this quotation mark that started right here, and then we're going to close the string with this one right here. Hi-Fi, hey man, do you work as a programmer, or is this just a hobby, Hi-Fi? It's just a hobby indeed. I'm a self-taught programmer, programming for about 20 years as a hobby. Never did it professionally. The closest I've come is I write a lot of software for the stream here. A lot of the software behind the scenes of the stream is actually my own code running in Python. Okay, so we have this function. Let's run it. All right, let's just say, you know, person say location, person 1 name, and person 1 location. Let's see if this works correctly. Okay. Let's run this module. So David says, I'm from Michigan. So it did work, right? It did work. So we ran this function. We defined the function right here. And then we ran it right here. We gave it 2 arguments. Person 1 name, David, and person 1 location, Michigan. And then it ran this code right here. Person name plus says I'm from plus location plus period. Let's go look at that, how it worked again. Right here. So David says I'm from Michigan. That worked. That kind of worked. That's kind of cool. But we have a few issues here. For one thing, person say location, it's not really intelligent. For instance, I can actually give it Derek's name here. Person 2 name. Right? Let's run this. What's going to happen? It's going to crash, do you think? I'm going to go here and actually hit F5. That'll run it. Derek says, I'm from Michigan. Well, no, he's not. He's from the moon. We established that already. That's because our function here doesn't really do anything interesting. All it does is it takes 2 strings, and it prints them off together. That's kind of lame. And likewise, we can't really add these 2 guys to a list of people because there is no people. There is no person 1. There is no person 2. In our heads, there is. But as far as Python's concerned, these are all just loose variables. Sure, I put a space between them. Right? That's for me to read, to make it easier to understand. But we don't really have 2 people. We have 6 variables. What we can do, though, using object-oriented programming, is take this concept of a person and turn it into something intelligent, something that Python understands. Let's define it right now. We're going to make a class here, guys. Cool. So that's how our code works right now. But now we're going to use classes to create objects in an object-oriented way. Let me actually break a line here. An object-oriented way. This will allow us to make our code more intelligent and, more intelligible. Not sure if I can spell intelligible like that, I think. I hope so. So Maelstrom says, Vencabot, why did you never do it professionally? I have friends that are programmers that work professionally, and what I love about programming, Maelstrom, Metalstorm, is the creative aspect. I love being able to have an idea and express myself by making something work, that was before unworking. Something that, might have been really difficult to do on my own. Now I can automate it. Now I can make my own games. I can make my own scripts. I can make my own functions that will, open up browsers and go to websites for me and download stuff for me. It's kind of cool. It's very creative, right, Chinchilla? It's very creative. But I have friends that program professionally. For one thing, they don't make a whole lot of scratch. It's actually less than you would expect. Because it's very, once you know how to do it, it's not that hard. Right? It's actually, once you know how to do it, it's really not that difficult. It's not really like a super skilled profession at the lower levels. And second of all, they don't get to make their own code. What they do at the lowest levels of working as a programmer is you take code somebody else wrote and you try and find bugs in it. You try and improve upon it. You try to find out why this client's complaining about this thing not working. Right? If you have a client that's complaining, it's your job now to figure out why it's not working and to fix it. And from what I hear from my friends a lot of the time, that means going through code that somebody else wrote 7 years ago, and they didn't know what they were doing. So it's just a bunch of very ugly, barely working code. You have very strict time constraints to fix it, and it's kind of a drag. You would like to rewrite it in a more intelligible way, but you're not really afforded that leisure, professionally. It's your job not to make it better, but just to make it work for right now. Which means, again, 5 years down the line, when somebody has problems with your code, they'd be like, what was this guy thinking? Well, dude, I was working under constraints, right? I didn't have time to do it the proper way. I just had to barely make it work. And that sounds really stressful to me. I don't think I really want to do that. There isn't really a lot of professional programming fields where you go in and you write a program yourself to do a job. That's not really what you do as a professional programmer. But as a hobbyist, that's what you do. So that's kind of what I like. I don't think I really want to do it professionally, to be honest. But it is a really fun thing you can do. Anyway, so here's our functional code, right, where all of our stuff is just very flat. It all belongs to the program. You have 6 variables and 1 function. It all belongs to this program, but it's not very intelligent. We're going to make our own code using classes and objects. Right? So basically, objects are created using molds called classes. Objects can own data, which are called attributes, and they can own functions, which are called methods. We're going to take our example above and reimagine it in an object-oriented way. So first of all, we're going to make a new class. So we know when we define a function, we use def to define a function, right? Then we space and put in the function name. We make a class, use the word class, and then put a space and make a class name. We're going to call it person. Right? Class person. And a person is not like a function, a class, so it doesn't really need like arguments. It just needs a colon. Class person, right? Cool. And it's going to have some attributes. Well, let's not do that yet. It's going to have a method. That method is going to be say location. Here's up Lambda. It says, oh my, what did I walk into? Well, I kind of disagree with some of that. Sure, that happens sometimes in some companies, but even lower level programmers don't typically do that. They'll still be writing their own code, designing stuff, probably with the oversight of a senior or a manager, but still. What you describe more sounds like someone in test or even SET, software engineering and test. I don't know, man. Sounds like you have some more experience than I do, for sure. But again, I've got quite a lot of friends that have gone through school to program, and they have been very dissatisfied with what they've ended up doing. Okay, let's make a function here. So basically, we have a class, person. We're going to define a function inside this class. We're going to call it say location. Welcome aboard, Lambda. Okay. It's going to take one argument, self. Okay. We're going to do the same thing we did right here. I'm going to copy paste this code, for instance. So let's copy paste this code right here for say location. Cool. But now we don't have any arguments. We don't have person name, right? We don't have that argument anymore. We don't have this argument person location either. So how is this function going to work? Well, we're going to use this one argument we have self, right? We have self. We're going to use, self dot, my name. And self.location. Right? So we have this self argument we get, and we're going to be using its attributes. Right? We learned before that dot meant like an apostrophe s. Right? It's like ownership. So we are going to be using this self object we got and use its attributes to print off some data. Coolio. And we have this method here, right? So basically we defined this function inside of this class block. And that means it's actually a method. Right? It actually belongs to this class, to this object we're making. You're probably right, Chinchilla, indeed. Lambda says, Venka, where did you learn this computer magic and how long did it take? I've been programming for about 20 years now. And if you guys are watching this channel, you might have noticed we have a series called Intro to Python. We're doing it right now, in fact. And we are in season 2. I'm confident if you go to my YouTube channel at youtube.com/Vencabot archive, you can learn this stuff in, a week. It's not that complicated. Our season 1 has, I think, 6 episodes. And in season 1, we started off as total novices. We had no idea what the hell we were doing. We'd never programmed before in our entire lives. And every day we learned new skills. And by the end, we had a fully working Pokemon battle. It's actually not that complicated. Not as bad as you would think. So Hi said, one thing I've never understood is what self is. Self refers to, well, it refers to 2 things in particular. Let me try and break it down for you, Hi-Fi. Self refers to the first argument of a method. It could be anything. But what the first, so when you make a method, guys, like say location, you always give self as the first argument of a method. Let's make another one. Let's just say, let's just go right down here. Make another method, right? We're going to call this one party. Print off self.myname plus, is partying. Right? One second, I'll be right back, guys. I apologize. No! Go to hell.
Repeat this after me. I'll never take on a god.
Somebody wait, guys. No! You repeat after me. Okay, so, I'm sorry, let me do this right here. So, self is the first argument that a method gets. And that argument refers to the object that the method belongs to. So I'm going to demonstrate that real quick here, guys. So we have this class that has two methods, right? Say, location, and party. And each of these methods takes only one argument, which is self. Every method must have at least self as an argument. That's the first one. And it will use self to get these attributes off of it, such as my name and location. So let's make a person now. We're going to say person1 equals person. So when you use a class to make an object, the class is the mold, right? The class is the mold you're using. When you use that mold to make an object, you call it like a function. You give the class name, and then you put some parentheses down. Just like when you're calling a function. This returns a new object of that type. So now we have this person, right? Now we can do some things to it. Well, one thing we can do with objects is we can give them attributes. Person1.myName, right, equals, we'll call this guy, hi-fi. That's his name. And we're going to say person1.location is, Twitch. That's where he's at. So now we can use this method. So we have these attributes, right, on this object. We defined them now. And now we can call that object's method, person1.sayLocation. Right? Let's run it, see what happens. Okay, so now hi-fi says I'm from Twitch. So hi-fi, what self is self refers to the object that this method belongs to. Right? So here we're saying, self.myName. Well, self.myName is the myName attribute of whatever is calling the function. So basically you can think of this like this, right? So person1.sayLocation is very much like if you were to do sayLocation person1. Right? The first argument of a method is the object that's calling the method. That's being called on, I should say. So, whatever's on the left side of this period is used as self. So, Chinchilla says, I'm more of a BI developer. Use SQL, okay. But I'll still go to Python on occasions if I need some sort of automation. Python's so great, it's very simple to understand, and very nice syntax. Middlestorm says, self is the object the method belongs to. Exactly. So, now we can also do person1.party. Right. So party is a method that belongs to this person object, right? Because we defined it within this class. And it uses self to get this attribute, my name. So let's run this code, right? Okay, so hi-fi says, I'm from Twitch, and hi-fi is partying. Right? So what's really cool about this is that unlike our code for, up here, the functional code, where we had a bunch of loose variables, person1 name, person1 height, with the, we're just making our own variable names, right? And we have this loose function, person say location. The problem with this is that you supply two arguments, right? Two strings, and it combines them right here, sure. But it's not intelligent. In fact, we already tricked it, right? By saying, person2 name, say person1 location. So it says Derek is from Michigan when Derek is from the moon. We established that earlier, right? Right here. That's again because these person1s and these person2s, they're not really things that exist as far as Python is concerned. They're only loose variables. Whereas now we have this person class, and now we can actually define things that Python considers to be cohesive, right? This person, it can have a name, it can have a location, it can have a height, right? Whatever. It can have anything. We can put up whatever we want. We can give it like a person1 dot. What else can we give it? Like a pet name. You know, a pet. You know, maybe it has a dog. Right? Whatever we want to add to this, we can add to it. So up until this very day, on this season of Intro to Python, we've been using functional programming, where there's not a whole lot of ownership going on. But from now on, guys, starting from now, we're going to be organizing our code in a way that's broken up into pieces that are much easier to understand on their own. Right? Not going to be a bunch of loose functions. Not going to be a bunch of loose variables referring to data that could be whatever. Right? We want to have our data be organized based on what it refers to. We're going to refer to this person. Right? We're going to have these functions that belong to this person. They do this thing. That's kind of cool. But we have even more power with classes. Right now what we've done here is we defined this person right here. We made a person, right? And we are attaching a bunch of loose attributes to it, right? We can define attributes forever. We can give it whatever attributes we want. Right? But what if we want for it to come with some attributes right out the gate? Right? How about we say like species is human. We know it's a person, right? We know it's a person. So now what if I were to print off, down here, print person1.species. Okay, well, we got a problem, right? Because we've never defined their species here. We defined their name. We defined their location. We defined their height and their pet. But we're going to try and print off their species. How do we know what their species is? Well, we know it because every person has this attribute right out of the gate. Species. Human. Let's see if this works. There, so it printed off human. Right? So even though we actually never made a species for person 1, he already has one because he was made from this mold, person. And person comes with some methods, and it comes with some attributes. Right? Species. This variable, species, belongs to this class. So when you make something from that class, it has that attribute already. It's kind of sick. We also overwrite that if we want to. We actually overwrite that right now. We can say, person1.species equals alien. Right? And we can print that off. Print person1.species. Cool. Cool beans. Let's do it. Right here, F5. Boom. Yeah, so he was a human. Now he's an alien. Right? So we printed off a species right here. That was human back then. Now we changed it to alien and printed it off again. Now it's alien. So these objects, these classes, these things we're making now allow us to organize our code in a way that's much easier to comprehend and to expand upon in the future. So let's go back and look at our game now. We're back at our game, guys. Now this game here is pretty functional, with a few exceptions. It's just a bunch of functions defined up here that make the game work, basically. These are things you can do in the game. And we have a bunch of loose variables. The game state, which has, chest is open, door is unlocked, door is open, player inventory, blah, blah, blah. We have the cave entrance command map, a bunch of dictionaries mostly. Then we have this while loop that runs to actually make the game run. It's all well and good. But here's my problem with this code, guys. Here's my problem with this code right now. We have this game state dictionary that contains the entire state of the game. Right? It contains everything you need to know, like basically your progress, right? Here's what it has in this dictionary. It has chest is open. That's false. It has door is unlocked. Okay, that's false. It has door is open. It has player inventory. Okay, it has a player position. But here's what's wrong with that. These are a bunch of loose variables inside this dictionary, but we could actually group them into conceptual objects. Right? What if instead of having this variables door is unlocked and door is open, what if we actually had a door that existed in Python, and that door could be unlocked, or it could be closed or open? Right? Right now we just have two variables, door is unlocked and door is open. What if instead of having two variables, we just had a door? What if we had a chest, right? So the chest is open, right? And the chest might contain a key, but right now, let's look at our chest is open code. Let's look at the get the key code, I should say. Excuse me. Let's look at the chest, right? The chest. Here is our open the chest code, right? We're making a function here, open the chest. It takes the game data as an argument, the game state, I should say. So first of all, we check if it's open, right? If the chest is not open, then print that off. Then we print off, does the player have the key? And if they don't have the key yet, we print off, there's a key inside of this chest, right? We assume if the player does not have the key yet, then the key is inside the chest. Well, that's bullshit, for one thing, because what if the player had the key and then he dropped the key somewhere else? Let's say you grab the key from the chest, you go to the next room, you throw it on the floor, right? So now we're saying, okay, if the player does not have the key, then the key is in the chest. Well, that doesn't follow. Doesn't really follow. So what if, instead of using all these loose, otherwise meaningless pieces of data, what if we actually had this chest as a thing? And that chest could be open or closed, and that chest could contain things, such as a key. Right? That'd actually be a radical change for our code that would make it a bit more sensible, a bit easier to understand. Well, fuck. Why don't we fucking do that? Piece by piece. We're going to actually be taking our code today for one more hour here and looking at the way the code used to work and trying to reimagine it in a more object-oriented way. First of all, let's start off with the chest. Let's change the way the chest works. Let's go up here to the top of our code. We have our function definitions, right? Let's actually go above our function definitions and make our first class for our game. We're going to call it treasure chest. Right, like that. Okay. So the treasure chest, it'll have, an inventory. Right? That's what's inside the chest. It starts off empty. It's a list, right? List of things that will be stored inside of it. And it'll have, an is open state. Right? And that will be false. It starts off closed. Right? And how about, instead of having this, this open the chest function is just sitting around loose, why don't we have a method that belongs to the chest, like chest.open? Instead of just saying, open the chest, assuming there's only one chest in the whole game, now that we have this class, these objects, we could actually manufacture a shit ton of chests, and each one could have its own open method that only works on that chest. Right? So I would say, chest, we're going to take this code here, open the chest, copy it, go up here to our new class, and paste it. Okay, so let's indent it to be inside this class. Right, and adding just 4 spaces to everything. All right, and we know that the first argument that a method takes is always self. Right. So now we have self and the game state. We're going to actually change the name of it too, from open the chest just to like open. Because now we are calling, we'll call it open lid. Right? Open lid of the chest. And now we're going to be calling it like, chest.openLid. Right? We're going to give it the game state here. So we're going to say, if not game state, chest is open, then print off this, right? Well, we don't need that anymore, right? We now have our own is open state. We don't need to know the game state anymore for that. We're going to say, if not self.is open, right? We don't need the game state anymore. We just need to know, are we open? Am I as a chest open? Right? If not, print out this data. There's a key inside. But we don't know there's a key inside, right? We don't know there's a key inside yet. Let's just open the chest. Exactly, Faust. Open chest. There you go. You open the chest. Now we change the game state. We're not going to change the game state anymore, right? We don't need the game state anymore. We're going to actually use our own attribute to save that it's open now. We're going to say self.isOpen. Excuse me, self.isOpen is now true. So it starts off as false, right? Self.isOpen starts off as false. But now we can change that value right here. Self.isOpen is now true after we open it. Okay. So now we're saying, elif not key in game state. Because we're saying, if the chest is open already, and the player doesn't have the key, say there's a key inside? Well, fuck that. Fuck that, man. Because we explained earlier that the player could grab the key and then dispose of the key somewhere else. So we can't assume that, the key's in the chest just because the player doesn't have it. However, thankfully, we have this inventory now. Oh, we have an inventory now. Okay. So how about, when they open the chest, instead of assuming there's a key inside, we print off everything that's inside the chest. Exactly, Mr. Steal Your Girl. It's an array. Now, in Python, it's called a list, and it's a little bit different from an array, but mostly similar. Welcome aboard, Mr. Steal Your Girl. How you doing, dude? You open the chest, now we're going to print off, we're going to say for, an item in self.inventory. So for every item in your inventory, or in this chest inventory, print off, there is, a or an, plus, an item plus inside. So for everything in the inventory, print off, there is a key inside. There is a sword inside. There is a piece of treasure inside. Mr. Steal Your Girl. Okay, so before the function, I'll leave for the follow, Mr. Steal Your Girl. We do programming here on Fridays, guys. We do programming here on Fridays. We usually do like gameplay on this channel, but on Fridays it's programming. So before we assumed, when you open the chest for the first time, there was a key inside. It used to be like this, right? You open the chest, there's a key inside, right? But I'm not going to assume that anymore. Now we're going to say you open the chest, and then for every item in its inventory, print off, there is a blank inside. So now our code is so much more powerful, right? Our code before was so simple. All it could do was show you there's a key inside this chest. But now the chest can hold anything dynamically. We can put things in the chest, take them out of the chest, and we can actually figure out what's inside of it, dynamically, just by changing a few things, making it more object-oriented. I made a problem here. Here we go. I actually put this quotation mark in the wrong spot there. There we go. Okay, so, yeah, I actually want to get rid of this. There we go. Let's try to fuck that up. So that's pretty cool. So now we open the chest here. Now we're just saying, if elif not key in game state, print off, it's already open, there's a key inside. Well, again, we don't know there's a key inside, but because our code is now object-oriented, we actually get rid of this part altogether. Or how about we just say, if it's not open, then print off, you open the chest. Right. We're going to say, else, print off, it's already open, and whether it's open or not, just print off everything inside the chest. Oops. There. So now our code for opening the chest is way simpler. Like, so much simpler than it was before. Because before it had to be like, well, is it already open? Does the player have the key? Blah, 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 blah. Now it just say, listen, you try and open the lid of the chest. It doesn't need the game state, right? It doesn't need the game state anymore. Because it doesn't use that argument. Let's get rid of it. All it needs is self. Right? So hey, you have this chest, right? Open the lid of the chest. If it's not already open, print off, you open the chest. If it is already open, else otherwise, print off it's already open. And then for every item in the inventory of the chest, print off, there is a something inside. And then we're going to actually say here, self.isOpen is true. If it wasn't already open, right? If it was already closed, if it was still closed, open it up. Cool beans. Cool beans! Alright, so now we have this thing called a chest, right? And it is conceptually its own object, its own thing. It's not just a bunch of loose data floating around. It is now a thing that can have data about it, like its inventory, or whether it's open or not. And it has its own method, things that it can do, such as be opened. Mr. says, how do you run Python programs on Windows? Do you use CMD? Yes, Mr. Sealer, indeed you do. So first of all, you want to download Python. Go here to your browser window. Go to python.org. Go to downloads. I sorry about all the stuff on the screen, all this text over here. That's just for your convenience, guys. Go to downloads, and you download Python 3.7.1. That's what you do. Once you've downloaded and installed it, then you can go to a command prompt. You go to here to start menu, type in CMD, click on command prompt. Right. Yeah, this thing I'm actually going to shrink it a little bit. I have this command prompt here. Then you go to, wherever your script is. In my case, I put them in this folder called Learning Python for you guys. And then we can, do py is your Python command. You don't actually run Python like this. You don't run Python in the script name, You actually just run it py. Py space in the script name in that folder. That would be, like, in my case, like classes example.py. Boom. It runs our class example from earlier tonight. So yeah, exactly, use the command prompt indeed. In this case, we're actually using idle. So in our earlier episodes of Intro to Python, we used Notepad to program with. But now we're using idle. Idle is a text editor that comes with Python. Once you install Python, you actually have idle already. You can run it by going to your start menu, going on down here to Python, and clicking on idle. Idle is a editor for Python. It's like an advanced version of Notepad, basically. And what's cool about this is that not only does it have highlighting to show you, how your text, how your code is broken up, but also it has this run option up here. You can run and run module to run your script. You can also just use F5 on the keyboard to run it. A little bit easier that way. I recommend that. But if you don't want to mess with idle yet, just mess with Notepad and use the command prompt indeed. We go through that in more depth in previous episodes on YouTube, youtube.com/Vencabot archive. Check the Intro to Python playlist. We used Notepad and command prompts there a little bit more than we did today. Okay, so we have this thing now. It's a treasure chest. Let's use it. So here we have, down here, we define our data, right? We have all our function definitions here, right? All these functions we've made. And we have this game state. This game state dictionary, and it has all this stuff in it. It has this chest is open value. Right. Well, now we're going to replace this with like a chest value. Right. So let's not do that quite yet. But basically, we're going to be removing these chest values and replacing them with a chest object that can do all kinds of fun stuff and have all kinds of data about it. This door values, the door is unlocked, the door is open, whatever. That's going to become a door soon, etc., etc. But first, let's go look at how we deal with getting the key. Get the key. It takes this game state. Okay, well, what we're doing now is we're checking the game state and seeing if the chest is open and if the player has the key already. Right. So let's do what I mentioned before, guys. Let's get rid of this chest is open value. Right. We're going to place this with, like, we're going to call this just chest. Right. The chest in general. And we're going to make this a new chest. We're going to say, well, let's make a chest first. Let's make a chest. So we're going to make a chest from our mold, or from our class. What's up, Glassjaw? We're going to say, we're going to call this, like, cave entrance chest, right? It's a chest of the cave entrance. It's going to be a new treasure chest. Boom. Then we're going to put a key inside of it, right? So it starts off, these treasure chests, they start off with an empty inventory, right? Right there. So let's put a key inside of it. We defined our chest. Let's say cave entrance chest dot inventory. It's inventory, right? Dot append key. So we're saying take the inventory that belongs to our chest and use that inventory's append method, and then put a key inside that list. So the cave entrance chest dot inventory is a list, starts off empty, and we're appending a key to that list. We're adding key to it. Cool beanzos. Okay. For this chest, we're gonna actually make this chest value be the cave entrance chest. Right. Cool. We have this object now, it's cave entrance chest, right? And now when we try to look around, or let's say we try to open the chest, we're not going to just be running open the chest. We're actually going to be running, cave entrance chest dot open lid. Right. So before we had this function called open the chest, but now we have our chest's actual open function. I'm going to actually shorten the name here. It's a little bit long. Let's call it treasure chest. Or let's call it chest. Let's call it chest for now. So our chest is a treasure chest. We're going to append a key to that chest inventory. We're going to give the game state the chest. There you go. Would you recommend Python for beginners? Hell yeah, dude. It's a really great language for beginners. It's, compared to other languages, guys, Python's syntax, the way that it reads on the screen, is much simpler. So you have languages out there like C++, very popular. Java, very popular, very powerful languages. JavaScript, very powerful, very popular. They're really great. One problem with them, though, is that they've been kind of hard to read. They have a lot of characters floating around for apparently no reason. Lots of semicolons, lots of curly brackets. Sometimes kind of hard to tell what is going on one line versus, why didn't they break it up over more lines than that? It's kind of hard to read. Whereas Python is very easy to read in comparison. It's very clean. Everything's indented very nicely. And I think it's actually pretty good for beginners. Maybe even the best beginner language. That's what I recommend it as a... I personally recommend it. Let's put it that way. I personally recommend it. Mrs. Tealier girl. Classes, I feel like I'm watching Elliot hack into Evil Core's database, huh? That's what you're referring to, Glassjaw. Do you have any books to recommend? Any books? No, I don't recommend books in general, Mr. Steelier Girl. I feel like that is a little bit antiquated. I think you probably don't want to go out there and buy an expensive book and then have it sit on your shelf for all time. Why don't you go check out a website? Such as here on python.org, the official Python website. You can go to documentation. Right, go to docs. Python 3 docs. And click on tutorial. It's a good way to learn. Kind of like a book. It basically is a book. Right, you can go through and learn all kinds of fun stuff this way. Or you can again watch YouTube videos, such as our own YouTube videos at youtube.com/Vencabot archive. Go watch Season 1, where we actually made Pokemon work. Learned a lot of fun stuff there in Season 1. There's all kinds of cool ways to learn Python. And I really don't recommend buying a book. Don't go out there and spend your money and have this thing sitting on your shelf. Just use a website or something like that. It's probably a lot easier for you. Well, Astronaut says, is that a hacker-type language? Serious question. Hacker-type language? I think there is no such thing as a hacker-type language. Any language can be used for hacking. By the way, I love Mr. Robot. Who wouldn't? Faust says, boy, I'm about to get up in that ass raw if you don't stop. Glassjaw. Be nice to Glassjaw, Faust. Sorry about the music. I'm going to lower the volume here a little bit. This music is from my friend Albdat, albdat.bandcamp.com. A little bit resonant sometimes, a little bit noisy. Okay, so, yeah, now instead of supplying this, this generic function, open the chest, we're supplying this method, open the lid, belonging to our chest. Right? And then we have this function called get the key. Right, well, now get the key's going to work differently, right? Go to get the key. The way get the key works right now is, hey, listen, is the chest open in the game state? And is key not in the player's inventory? Then say you got it. Then add it to the inventory, right? Otherwise, say you already have it. Let's go Python. I'm a big fan of this guy's work, Faust. My friend Albdat. Go raise the volume here a little bit, guys. Okay, so, it works differently now, right? We don't actually check, chest is open in the game state. We're going to check, if game state chest, so that's our actual chest object, check its is open value, and key not in player inventory. That's a problem, right? It's a bug right here. For now, we're saying, if the chest is open, and the player does not have the key, then give them the key. Okay, well, no. Because the player might have picked up that key and then dropped it somewhere else. So just because they have the key does not mean the chest contains the key. However, we now have an actual chest with an actual inventory. We can just check that. So instead of finding out, if the player has the key or not, we're just going to say, and game state chest, that's our chest object, dot inventory, right? We're going to say, and key in, right? and the key is in the chest inventory. Then say you picked up the key, add the key to the player's inventory, and then remove the key from the chest inventory. Boom. There you go. So now the actual chest itself has its own inventory we can add things to and remove things from, which is going to come in handy later. Glassjaw says, by the way, Vencabot, 3S on New Year's Day would be a great way to start 2019. I think a lot of guys are going to have a hangover at Glassjaw. I think a lot of guys might not want to run a tournament on New Year's Day. That's my feeling. Likewise, I think we're actually not going to play it on Christmas either. Apologies for bombarding your stream with 3S. Oh, no problem, Glassjaw, no problem. We're going to say, otherwise, if the game state chest is open and key in a game state player inventory. Okay, well, this is already, we don't need this first part anyway. So elif, the key is in the player's inventory. Then say you already got the key. Right. Else, you don't see a key. Right? If the chest is closed, then you don't see a key. Right. Coolio. I've been meaning to ask you about how you feel about non-Python talk and Python. I don't mind at all. Here you go. So you guys can talk about whatever the hell you want. I might not always read it, because I might try and focus on Python while I'm streaming this, but you guys can discuss whatever pleases you. Whatever pleases you. I don't mind it at all. Okay, so now we have this chest object. So about that race for no bones. All right, so we have this chest object now. It has two attributes: an inventory, which is what it contains, the list, and whether or not it's open. Then we have this function called openLid, which will, open it if it's already closed, and then show you what's inside, which is cool. I think that our game should work now. We changed a few things around. Whenever you change stuff in a program, it might break things. Right? I think that our game should work now. Let's see if it does or not. If it doesn't, I'm going to do some more stuff. So let's hit F5 to run this code. You're going to keep what you want to do. I want to look around. Whoa, that's not right. Look around. There you go. I'm sorry, that's just a bug in idle apparently. Okay, so I can see that there's a treasure chest, so that's fine. Let's open the chest. Okay. So this is where things are going to break if it's going to break. Okay, here's where it broke. Okay, so it says open, it takes one argument, but two were given. Okay, let's give it the... oh, right. Right, because it's getting the game state. Okay, so the reason why it crashed, let me show you the error message here again, guys. So it says openLid takes one argument, but two were given. Right, so we actually gave this thing two arguments. Let's look at the method. So the method only takes one argument, which is self. All it needs to know is, its own chest. Once it has its chest, then it can check if it's open or not. It can move the inventory around. It can look at what's inside the inventory, etc. But our code down here for calling methods, for calling functions, always supplies the game state as an argument. So it got an argument it didn't really need. Well, why don't we, for now, just give it this argument, this dummy argument, right, that we're not going to use. I'm not sure if we're going to have time today, guys, to actually make this code fully object-oriented the way I would like to. So it's kind of like a little intermediary compatibility measure between our old code and our new code. So it's going to take the second argument now, but it's not going to actually use the second argument. In fact, I'm going to put a comment here. Bug. Game state is included for compatibility. Remove this unused argument. Right, so later on, we're going to fix that later on. Right now, it's taking this argument, doesn't really need, but just to improve compatibility. Let's make sure it should run now, I think. Let's try it again. Let's open the chest. Okay, now it works. Since we actually called our new code, it says you open the chest, there is a key inside. All right, that's cool. So I actually ran this method here, and what's cool about this guy is that it printed off everything that was inside the chest. Now, why is that interesting? Because our old code, which was not object-oriented, it was just functional, it had this, the player knew there was a chest there. and there's a key inside that chest. Except that as far as Python knew, there was no such thing as a chest, right? It didn't contain anything. It was just a bunch of loose variables, such as chest is open, and, player has key, etc., right? But now we actually have this thing in Python that's an object called a treasure chest, and it has an inventory that is a list. So what's cool about that is that before, in order to see what was inside of that chest, we would need to check a bunch of variables. Does the player have the key? Does the player have the calzone? Does the player have the dog leash? Does the player have the screwdriver, right? If we wanted to figure out if the chest had them. But now the chest itself can contain anything. In fact, all we got to do to add more stuff to it is just like this. Watch. Chest inventory dot append. Calzone. Chest inventory dot append. Screwdriver. Right? So before, it would have been many, many lines of code to add things to that chest. But now, because we simplified our code by, again, using a more advanced concept, the concept is more advanced, the code is now simplified. If we run this program now, and we open the chest, that chest has 3 different things in it. Right? All we had to do was just append them to this list of inventory. Right? So now our program, again, is simpler. Our code is simpler, and in the future, we can use this chest to contain all kinds of objects and interact with them in interesting ways. So our game just got a lot more interesting. We have these treasure chests now that they are not just an abstraction of a thing that might contain a key, which was what they were before, right? Before they were just like a thing that might contain a key. Now they're actually a box that can hold anything. We can put all kinds of cool treasure in them now. It can vary from chest to chest. That's kind of sick. It's kind of cool, right? So we can get the key now. We can't get the calzone or the screwdriver out there yet. We don't have commands for that yet. But what if we did have a command for that? I'm not sure I want to get into that right now, but I'm going to do an example of how that would work. So we have this method here, open lid, chest.add item, chest.remove item, yeah, that too. But what we can do here is we have this open lid. Good night, Hi-Fi. Yeah, I'll see you around next Friday, Hi-Fi. So guys, we are a 40-hour-a-week stream here. We stream a lot of gameplay here on Mondays, Wednesdays, Tuesdays, Thursdays, and Fridays. We're going to be doing some Mario 64 here in about half an hour. But on Fridays, we program, do programming classes here from around 6 to around 9 p.m. Eastern Time. Now, starting in January, it's going to be a much more common thing. You're going to see more programming streams here, not just on Fridays, maybe on Mondays, Wednesdays, and Thursdays, too, around the same time, around 6 to 8 probably. So definitely stay tuned, guys, for more programming streams on this channel. We're kind of shifting some focus away from gameplay, a little bit more towards some programming here. Anyway, we're going to add a new method. We're going to add a new method called take. Okay, so we have one method here called open lid of the chest, but we're going to do chest.takeItem. Right? Take item. It's going to take self, and then the item string as an argument, and then the taking, or how about just the player, right? Just the player. Whoever has the inventory. So now our chest has 2 methods, right? Just for now, it has 2 methods. One is open lid. So you're going to open lid of the chest, and now you can take items from that chest. Right. So take items going to take an item string and a player who has an inventory. Right. So now we can say, print off. We're going to say, first of all, is this item in the chest at all? So we're going to say, if item string is in the chest. Right, so if we have this item, then do the thing, right? Do the thing. Say print you got, or how about you took a plus item string plus, sorry, I did it wrong again, plus item string plus from the chest. You took the thing from the chest. Then we're going to say self.inventory.remove item string, right? Remove the item from the chest, and then player.inventory.append item string. So now we have a way to get out the calzone, the way to get out the screwdriver. The only problem is that because we have limited time today, we're probably we're not going to have time to make the player into an object that has its own inventory. Right now, the player inventory is saved loosely in this game state variable. Right, this game state variable here, we're going to be phasing out very soon. But it has this player inventory value that has an empty list. Right? But in the future, we're going to have a player object, and that player can have its own inventory, and it can very easily take things or put things into the chest using this method right here. So we're not going to use this method quite yet, but this method here will allow us to get the calzone and the screwdriver, out of that chest later. Hope you have a good night, hi-fi. All right, so now we have this chest that we can open up and see what's inside, and it can contain anything now, not just a key. That's pretty sick. But we also have this idea of this door. Right, let's go down here to the game state. We have the door is unlocked variable. We have the chest is open, the door is open variable. Right, so we have these values that are just loose in the ether, and we want to actually condense them to being a thing in Python that exists and has its own attributes. Right, not just a bunch of loose variables floating around. Make a door. Let's make a door. Right, class door. Okay, it has a couple of attributes, right? Is it locked? Starts off as true. It's locked. Doors are locked. Well, yeah, let's assume that all doors are locked. No, so let's make them unlocked at first, right? They're always unlocked. Then we're going to say, is it open? That's also false. So it starts off unlocked but closed. And it has a method called, how about unlock? Right? You can unlock this door. It takes only one argument, which is self. It only needs to know about itself. We're going to print off, well, for let's just say, if self, because we have access to self, right? It's our argument here. We have access to self. If self dot, is locked, then print off. Oh, we have to know if they have the key, though, huh? Whoa. Well, for now, let's apply the game state, then. We need that for compatibility anyway. Right, give them the game state. We're going to say, if self.is locked, then we're going to say, well, first of all, if it's locked, right, does the player have the, do they have the key? If game state, player inventory, right, we're going to say if the key's in there, if they have the key, right, then they can unlock the door. So we're going to say print, you use the key to unlock the door. Okay, then we're going to say, self.isLocked is now false. Right, so now the door is unlocked. Now we're going to say, otherwise, if they don't have the key, print off, you don't have a key. Okay, so we're saying here, when they try to unlock the door, we need to know two things. We need to know what the door is, which is self, and we have to know what the game state is, so we figure out if the player has the key or not. Right. So we're saying, if the door is locked, then if they have the key, print off, you use the key to unlock the door. And then self is locked becomes false. Otherwise, if they don't have the key, print off, you don't have a key. Right, that's fine, it's whatever. Now we're saying, hey, listen, else, so if self is locked is false, so if the door is open, just print off, the door isn't locked. There you go. So now we have this function here for unlocking the door. All it does is if it's locked, do you have the key or not? If it's not locked, let's say, hey, the door's not even locked, dude. Relax. Okay, so now we have this unlock function. Now how about opening the door? Right, so just say def, open, well, like open up, right? I don't want to use the word open, guys, because open is a built-in function in Python. So you don't want to try and, you don't want to be confusing with your code by using terms that Python already uses, if you can help it. So open's a function in Python for opening files. I'm going to actually call this open up. Let's just open up the door. It starts off as self, and doesn't need to know the game state, right? Except for compatibility reasons. We're going to actually do that in a second here. So we're going to have open up. We're going to say, listen, if self dot is locked, right? If the door is locked, then print off, you know, you can't open the door. It's locked, right? Otherwise, you know, if the door is unlocked, then say, you know, print, you open the door. This is actually bad code here. I'm going to explain why in a second here. We're going to change our isOpen value. So self.isOpen is now true. Okay, so our code has a couple problems here. Let's fix this, right? So first of all, you can lock a door while it's open, right? So it says here, it checks if the door is locked. If the door is locked, then you can't open it, right? But here's the problem. The door might already be open. So first of all, let's check that first, right? First of all, we're going to say, if self.isOpen, how about, you know, if it's closed, right? If not, self.isOpen. If the door is closed, then find out if it's locked. Okay? If the door is not locked and it's closed, then open it up. Right? Else, you know, if the door is open already, just print off, it's already open. So whether or not it's locked, if it's already open, you can't really open it, right? So there you go. So now we have this open up method on this door object, right? So now the door can be unlocked, and it can be opened up. All open up does is it checks if the door is already open, make it a property, and do door.opened equals true. Lol. Yeah, we have is open values. What we're talking about, middle storm, is open property or attribute. We call them usually attributes usually in Python. You know, in JavaScript they're called properties. Same diff. Yeah. So we have this open up method and this unlock method. Cool beans. So now let's go down here, and instead of having these loose values, these loose ass values for door is unlocked and door is open, why don't we just make this thing in the game state called a door? We have this door now, right? And it's gonna be door. We're gonna make a door right here. We have a chest. Let's make a door. Door equals door. There you go. No, I mean use property. The decorator. Oh, I see. Actually, a descriptor. Right. Decorators. We're not gonna do that yet. I love decorators, but I think we've never actually done that on. So, Intro to Python is really more of a beginner-focused kind of content here. I think even in Season 1 we never used decorators. Maybe one day we'll get into that. Not really that important for novices. Okay, so we have this door now. We just made it, right? We used the class door, and we called it with these parentheses, just like with treasure chest right here, to get a door from that mold. The class is the mold up here. We defined what a door is, what a door is like, what a door can do, and now we're making one of these doors. Right? So it starts off unlocked, and it starts off closed. All right, well, we want our door to be locked, right? So we made a door. Let's lock it. Door.isLocked. I'm going to change that from false to true. Now the door is locked. Coolio. And now we have the door saved as our door, right, in our game. Awesome. Let's use it. So we have this entrance map, the cave entrance map, where instead of having open the door and unlock the door, be these loose functions, we're going to have open the door become door dot open up. Right? Open that door in particular, right? And unlock the door is going to be, instead of just being unlock the door, it's going to be our door, its unlock method. Cool. Let's delete some functions, shall we? We don't need open the chest anymore. Right, and we don't need the door-related functions anymore. Open the door and unlock the door. These can go away now. Cool. Awesome. Okay, so we still have one more door-related function, though, right? The enter the door function. So the way enter the door works is that enter the door will look at where the player is, And if they're on one side of the door, they go to the other side of the door. Right? What's up, Kenny? So why don't we give our door class places that can be on either side of it? Right? So what should we do for like the places on either side of it, huh? Well, let's give it, let's give it 2 variables or 2 attributes, right? We'll give it like location A is going to be, start off as like, we'll default it to some random shit like place A. Right. And we can have a location B. It's going to be place B. Right. So now it has these 2 locations, one on each side of the door. Now we're going to have this a new method to this door. Enter. So we're going to enter this door. And we're going to say, let's just copy paste our enter code, right? Let's go down here to our code where we entered the door before. Down here, enter the door, right? Let's see how that works. How's your day been, Kenny? Our game is getting pretty sick. We're actually taking our old functional code and making it more object-oriented. And what's really cool about that is that we're able to add new features much more quickly. These doors and these chests are becoming much more interesting. Okay, so let's get rid of this old function definition. We're going to actually indent all of our code here. They're not all indented correctly. Walmart with the lady, huh? Hell yeah, Kenny. What are you buying, dude? Anything cool? A bunch of lame stuff. Okay, so here's the way that it used to work, right? You used to use the game state and check if the door was open that way. Well, we don't need that anymore. Now our actual door itself knows whether it's opened or not. So let's not check that. Let's just check, if self dot is open. Groceries? Who buys groceries at Walmart? Probably a lot of people, huh? So print off, you walk through the door, right? Now we're going to say, if the game state dot player position is cave entrance, then send them to dark room. Well, that's kind of closed-minded. It's kind of closed-minded, right? Because all this door can do now is send people from the cave entrance to the dark room, or from the dark room to the cave entrance. Right? That's the old way of thinking. We're leveling up our game, guys. Now we can have doors that go from anywhere to anywhere. Let's go. How do we say, if the player position is self dot location A, right? Then send them to self dot location B. So now every door that we make can have custom location A and location B values. And if you're on one side of the door, you get sent to that side. Right? Otherwise, if they're not at location A, then you can send them to B. But if they are at location B, then send them to location A. Right? Cool. We're going to assume that if they're interacting with the door, that they're in one of those 2 spots. That could cause a bug later on, guys. But that's always a juggling act when you're developing any kind of program. Is you have to assume that whoever's using your function knows how to use it. So in this case, we're going to say, if you're at location A, then go to B. Otherwise, go to A. We're not even checking if they're at location B. Right? So if they're in location, some other crazy location, and they use our door, they will go to location A. That's a bug, right? We don't want them to be able to go anywhere if they're not near the door. But we're assuming if you're using the door, then you're near it, right? Which might be a bug later on in our code. For now, we're going to assume that's the case. Good night, Kenny. I'll see you around, homeboy. Good luck buying all your cool stuff. I'm going to look for a mic stand arm, huh? At Walmart? I'd be surprised if we can find one. Maybe try Amazon. Okay, so we're saying, if the position of the player is in location A, then change their position to location B. Otherwise, send them to location A. And then if the door is closed, you can't enter it, it's closed. Right? So let's put our game state in here, again, for compatibility reasons for one thing. We also need it right here for compatibility reasons, at the very least. Awesome. Awesome. So, now we have this dynamic door. Now we can actually have more than one door in our game that goes to different places. That's kind of cool. Let's go do that. So let's go to our door, and let's change the locations, right? So we're going to say door dot location A is going to now be the cave entrance. And door dot location B is going to be the dark room. Awesome. Kind of like this song. Okay, so now we have this door thing. So before we just had this couple of loose variables, right? A door, is it open? Is it closed? Now we actually have a door object that itself can be open or it can be closed. It can be locked or unlocked, and it can actually go from a point A to a point B, or from a point B to a point A. And because of how we programmed it now, we actually have more than one door. We have more than one chest. A cool thing about object-oriented programming is that you define these molds, these classes, and you can mass produce things from those molds. Before we only had one door and one chest. Now we can actually have as many doors and chests as we want. Nice! Thank you for the follow, so-and-so. I'm sorry, I missed whoever was following us now. But thank you, dude. I appreciate that in any case. Hope you can get in the chat and let me know your name and stuff. But it's a pleasure having you. We're about to end our programming stream here in about 20 minutes, guys. I apologize. We stream here 40 hours a week, mostly gameplay. On Fridays, we do this Intro to Python class for you guys that are new programmers. I kind of try and break down how Python works and how we can do some game dev, very simple game dev. But we'll be doing more of this in January, more than just once a week. Okay, so we have this chest now, we have this door now. Let's see if we can make this thing work. We have to change the commands, right? We have this cave entrance command map. The door, open up. Unlock the door, door to unlock. Thank you for the follow, Lazy Norm. Welcome aboard, dude. We do a lot of programming here on this channel on Fridays. Very soon we'll be doing more than just Fridays. That's going to be in January. Enter the door can go away now. Now instead of having enter the door, we have door.enter. Right? Coolio. Let's go delete this old function we used to have called enter the door. Right now we're in the process, guys, of changing our old functional code that worked pretty well. The game was really great. Very simple, but pretty cool. For a beginner, that is. And we're changing its old functional code to more object-oriented code, so we can actually make our game better, quicker in the future. Because now we can actually add as many chests as we want very easily, as many doors as we want very easily. That's kind of cool. Let's see if it works at all. Might have some typos in here. Let's run it! No, so enter the door is not defined. Where is that used at? Line 167? Oh, here the cave entrance map. Right. Here we go. The dark room, I mean. Let's change this from enter the door to door.enter. There we go. We got rid of our old function. We have a new method now we're using instead. Let's run it now. Awesome. I'm in a cave. What do I want to do? I want to open the door. Okay, we've got some bugs here. I'm sorry. Open the door. Okay, you can't open the door. It's locked. Okay, so the door is locked. That's what you want, though, right? So let's unlock the door. Because you don't have a key. That's what we want, right? We don't have a key yet. Let's get the key. You don't see a key. Well, let's look around then. Okay, the cave is dank. There's a treasure chest. There's also a door. There's also a torch. Okay, well, let me open the chest. Okay, so inside the chest, there's a key. There's a calzone. I don't know if it's still good. There's a screwdriver. Well, let me get the calzone. I can't do that yet. We don't have that function programmed in, right? We need to fix that on next Friday. But we can get the key, though. There's a command for that. Get the key. Hey, I got the key now. Nice. Hopefully we can unlock the door then, right? Let's open the door again. Okay, it's locked. Let's unlock the door. Hopefully this works. Use the key to unlock the door. Let's open the door. Okay, I open the door. Okay, let's enter the door. Okay, I walk through the door. Did it actually work, though? Look around. Hey, I'm in the dark room. It's too dark to see. Let's enter the door again. Okay, you walk through the door. Let's look around again. Hey, we're back in the cave entrance. So, guys, that's kind of sick, right? We made a door object, and we defined its location A and its location B. And now we can walk back and forth through it by entering it. That's kind of cool, right? But in the future, we can actually make more doors. We can make doors that go from point A to point B in all kinds of different locations, right? And before, the way our code used to work back in the day, that would be very difficult to do because our code was very, very limited by its by the concepts we were aware of at the time. As we continue working on this script, guys, and making our game better, we're going to be learning new tools for our Python tool chest. Right? For our day 1, our day 2, and our day 3 streams, every day we learned a new skill in Python, and every time those concepts may have evolved. The concepts were more difficult to understand individually, but once you understand them, they made our code simpler. And today, by learning classes and objects, we can actually expand our game very quickly and make it much more interesting. And we'll be doing that more on day 5 next Friday, because right now we're almost out of time, guys. We have about 15 minutes left. Let's carry on, though. So we made our chest into an object, made our door into an object. One thing we can do now is make the player into an object. We have this player inventory value and this player position value, right? Maybe we should have this thing in our minds that is a player, right? We have these two loose values that, as far as Python knows, they are not associated at all. There's two loose variables. But we can actually associate them by making them both attributes of a class. Instead of having this loose player inventory, why not have a player and have that player have an inventory? Instead of this player position value, why not have a player and have him have a position? Right, let's do that right now, why don't we? Let's go up here. Right, we have this treasure chest class. We have this door class. Let's make a player class. Class player, right? And we know he has two attributes right now. Right? He has an inventory. It's going to be an empty list at first. And he has a position. Right? He starts off at nowhere. The player starts off nowhere. Right? Cool. So that's all we know about him right now. But now we at least have this thing called a player, and he has stuff about him. Right, so first of all, why don't we go down here, and we defined our chest, and we defined our door. Let's make this player. We're going to say, player equals this player object. We're going to actually use that mold and make a player. As you guys know, you take the name of the class, which is like a mold, and you put some of these parentheses past it, a couple of parentheses there, that will actually make an object from that mold. So we have this player mold, and we're spitting out a player. There we go. Now we've got one. Let's change his location, his position, I guess we called it, right? And make him actually go from nowhere. We're going to actually change that to the cave entrance. There you go. So he starts off at nowhere. We're moving him to the cave entrance. There you go. Now, next Friday, guys, we're going to be talking more about init functions, right? We're actually init stuff, like the position. But for now, we're just going to be assigning this values manually like this. If we made a player, we moved him to the cave entrance, he still has an empty inventory. That's what we want, right? So now we can get rid of this player inventory value and the player position value, and instead just have the game state keep track of this player. Right, now we have this player object. Right. Now he has his own inventory. He has his own position. We just have a player now. He has attributes. That's kind of cool. But it's going to cause some problems in our code, because a lot of our code revolves around knowing the old style of player position and the old style of player inventory. We're going to have to fix a lot of stuff here now, guys. First of all, we know some code down here that uses that, right? The current position is GameState.playerPosition. Well, let's get rid of this line altogether, right? Don't need that line anymore. Because now we have this player.position, which represents our current position. Right? Wherever the player is at, the player's position. We can use that now, pretty cool. All right, so where else is this used here? Command, player command, blah, 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 blah. We know we use this a lot, like for get the key and stuff, and get the torch. We rely on this player inventory value in the game state. Let's go up here to the treasure chest, for instance, right? Take item, for instance. It says, we actually had this code that was kind of we preempted this, right? That's fine. Let's go down here to the door. We check the game state to see if they have the key, right? For unlocking the door. If key is in game state, player inventory. Well, now we don't have this player inventory, right, in the game state. Down here. The game state. We don't have no player inventory key anymore. However, we do have a player key. And the player key is mapped to the player. So let's go up here then to unlock the door. We're going to say game state player. So get the player out of the game state. There's the player object. And then check his inventory. There you go. Awesome. Okay, now down here, for instance, we have these game state player position. Now, player position is not a key anymore inside the game state dictionary. However, we can just get the player out now. The player there and check his position. There you go. Likewise right here. Get the player out of the dictionary using the key player and reset his position to this location B. Awesome. Right here. Do the same thing. Get the player out of the dictionary and reset his position to this new value. Awesome. Awesome. So what else we need to fix down here? Well, a few things, right? We have these stairs. Now, the stairs are very much like the doors. In fact, let's go look at this real quick. We have this staircase, right? Let's go down here to descend the staircase. Okay, so if you have this torch, then... Oh, yeah, right. That kills you if you don't have the torch. I forgot about that. It kills you if you don't have the torch. Let's make a staircase object, I guess, huh? For now. Let's... Because the way the staircase works is very much like a door, right? It actually uses the player inventory to check stuff. For like unlocking the door, basically. And it has this, it kind of moves you from one side to the other side, right? It changes your position. And then we have ascend the staircase. Which, again, it moves you from the bottom to the top of the stairs. Very much like a door. It's just like a vertical door, right? Hashtag doors are just, you know, horizontal stairs. Okay, so let's go up here and make some stairs, right? Very much like a door. Very, very similar to a door. They can't be locked, though. They're not really open or closed. But they do have a location A and a location B. And this enter method. Right, now we're going to be learning next week about inheritance. For now, we don't actually have that yet. Let's just make a staircase. In fact, we're going to copy-paste our door code. Right, it's just like a door. It's just stairs. So let's paste that. Okay. So our new class is going to be called stairs. And they have to be lit up, right? They have to be lit up in order to descend them or you're going to die. Right, so we're going to say, you know, they're not locked, they're not open or closed. But they do have location A and location B. You can't unlock the stairs. I don't need to have that. You can't open the stairs. There's stairs. But you can enter the stairs. But you don't walk through the door. You, what we're going to say here, you know, if you're at position A, go to position B, right? But also print off. You descend the stairs. Right? Otherwise, you're going from the bottom to the top. Print off. You ascend the stairs. Okay, cool. Also, it doesn't have to be open or closed, right? It says if it's open, then you can do this, but fuck that. This is not a door. It's just stairs. So just, you know, unindent this stuff. Get rid of that block altogether. And let's see if this works at all now. I'm actually going to fix some stuff here. I'll have to change the way Get the Torch works. That's fine. Okay, let's go down here to Get the Torch. So look around requires the player position as well. That's fine. Let's not use that. We're going to use look around for now. Let's see here. Get the key. Okay, that requires the player inventory. Let's actually change this to use the player dot inventory. Okay. Okay, blah, blah. Again, player inventory, you don't have a player inventory key anymore. Instead, we're using this player inventory attribute. Okay, you got the key, that's fine, blah, 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 blah. Leave the cave, I'm not going to do that in our code here. I just want to go down the stairs. Get the torch, we don't need that for now. You don't need to send the staircase in there, don't need to get the record, don't need to send the staircase or listen to... Okay, we're fine, guys. So let's go down here to our command maps. For descend the staircase, we're actually just going to use stairs dot enter. And for the basement, we're going to ascend the staircase, we're going to actually just use stairs to enter again. Very simple. Let's make some stairs. So we have this door, right? We're going to make some stairs. Stairs equals stairs. Right, we're going to use our mold, our class, and manufacture some stairs and call those stairs stairs. We're going to assign them a location A and B. So stairs at location A, which is the top, make that the dark room. And then stairs dot location B is the bottom, make that the basement. Is it Userman? Have we met before, Userman? I'm sorry, I probably don't remember you from last time. It's probably been a while, huh? Okay, because I'm live here 40 hours a week, dude. I'm here all the time. So let's see if this code works at all. Okay, I want to open the chest. It was a bit ago. Huh? What was it for? What were you here for? This intro to Python, Userman? Or was it for a game we were playing? Get the key. Unlock the door. Open the door. Enter the door. Now let's descend the staircase. Hey, it worked. Okay, let's ascend the staircase. Hey, it worked. Okay, so let's look at why that code worked and how it worked and how we're going to improve it here. So we have this stairs object, right? The stairs class right here. And it has a location A and a location B. Stairs have one method, which is enter. So you can enter stairs, all you can do with them. And what it does is it takes the player's position and it checks it. If you're at the top of the stairs, then it sends you to the bottom of the stairs. And if you're at the, if you're not that way, if you're not at the top of the stairs, it sends you to the top of the stairs. Right? So cool. But we have a problem. The old staircase would kill you if you didn't have a torch. So here's what we're gonna do. We're gonna say, hey, if you're at the top of the stairs, then, you know, if not torch in, you know, the player's inventory, right? The player's inventory. If they don't have the torch yet, then, you know, print, you tripped over some stairs in the dark and died. You're dead. User says, I got addicted to Smash Ultimate for a while, so I was not in programming streams much for like 12 days so far, huh? How you enjoying the game, dude? I don't remember the topic of the last one I caught you on, but it was a learning thing. I think it was the basics. We're still doing basics here, in fact. This is we're doing like a new program. I think it's probably, excuse me, it's probably Pokemon last time, maybe? But now we're doing like an adventure game. We're gonna have the player die if he tries to go down the stairs and he has no torch. It's too dark. We're gonna actually change the game state now. So we're gonna say, you know, game state dot adventure is ongoing is now false because you died. Diacemet says, what guide do you follow? I'm not sure I understand, Diacemet. I don't follow a guide. I like the game, but the online needs work. Lower ranks throw you into weird rule sets. Yeah, I wish you could like make like a hard rule, right? Like I don't want to go to play these other modes. I heard that it kind of like treats your preferred modes as like a recommendation. It's kind of weird. Okay, so now our game is a little bit more involved. Now our staircases will kill you if it's too dark. Yeah, exactly, Diacemet, indeed. I know Python, I'm teaching it here. Okie dokie, Smokey. So we have this, you know, the staircase now. And if you're at the top of the stairs, right, if game state player dot position, if the player is at the top of the stairs, self dot location A, then if they don't have the torch, then they die. Otherwise, if they do have the torch, then they can descend the stairs. There you go. So now let's try this game again and see if we can get ourselves killed. Right, what you want to do, I want to, you know, open the chest. I want to get the key. I want to unlock the door. Open the door. Enter the door. And I'm in the dark room, right? Let's descend the stairs. This should kill me, I think, right? Dark Souls, text edition, exactly. Oh, there it goes. You tripped over the stairs in the dark and died. Game over. Okay, so we can get game over that way now. That's kind of cool, right? But if we were to restart the code, like this, and then get the torch right off the bat, it's on the ground here. Oh, I can't do that yet. Right. I can't do that yet. Because we changed the way that works. Let's go fix our code. So let's look at our get the torch code. Okay. Here's right here. Okay, so we don't have this inventory thing anymore, this player inventory. Let's say if torch not in player in the game state, with the player object, dot inventory, then you pick up the torch, and we're going to append that torch to the player's inventory. Actually, make this code even better next time, guys. Actually, we're out of time here. This is going to be the last change we make here. Okay. You already have the torch done, but that's fine. Okay, so now we got the torch. Let's make sure we have a command for that. Cave entrance. All right. Get the torch, just get the torch. That's fine. Let's run the code here. How's the current scene being managed? It's being managed by this game state dictionary here, userman. We have this game state object, and it's a dictionary, and it maps the things we got to know to the data we got to know. Right now, we've actually made it much simpler today than it was before. Basically, it records the state of the game, and as you advance, these values get changed, etc., etc. And every function right now takes the game state as the argument. So every function here can know how the game is going and change things. That's kind of how it works right now. Let's run our game here before we end the stream here. Let's do this. Boom. So can I get the torch now or not? Okay, now I get the torch. Okay, cool. Awesome. So now let's open the chest. Get the key. Unlock the door. Open the door. And then enter the door. And now I have the torch, right? So I should be able to descend the stairs now, safely. Oh, I can't do that. Oh, something's wrong. Descend the stairs. Where's our bug? So we've got a key error. That's a neat way of doing it. I did the longer component way, but I tried to text a component way, huh? How do you mean? Out of curiosity, user man. How does that differ? Okay, so now we can descend the stairs, but with this game state, huh? If torch... Oh, here's our problem, right? There is no player inventory. So, if torch in game state player dot inventory. Okay. Nice. Now we're checking the actual inventory of the player, not our old player inventory game state value. That's how we did things back in the day. We're smarter now. We're stronger now. Let's run this. Get the torch. Open the chest. Get the key. Unlock the door. Open the door. Enter the door. Now I should be able to descend the staircase safely. There we go. Nice. A scene class has functions to handle interaction with default behaviors and parents. Oh no, that's what we're doing, user man. So basically, today's the day we introduce classes. As you guys know from our previous streams, Intro to Python, every day we introduce a more complex idea to Python. We're kind of adding to our tool set. Today we introduce classes for the first time ever. So our old code here is kind of whack, to be honest. That just refers to all these functions that are just loose inside of our program here. What a userman is saying is that in his text adventure, he actually used a class to do that. In our next stream of Intro to Python Day 5 for this text adventure, we're going to be doing that same exact thing. We're using a class to manage our state, rather than just a bunch of loose functions and this dictionary. But yeah, so this is going to go the way of the dodo next week, guys. Don't get too attached to it. We're going to make our code even better next time, a little bit more flexible, and make our game easier to expand in the future. Okay, so before we call it an end here to this stream, why don't we make sure that the game is fully working again? So I think most of it's working now, except for a few of these functions. We can get rid of the descend the staircase now, because now we have a method for descending the staircase, and for ascending it too, right here. Get rid of these two functions. And so all we have left really is so get the torch works now. We can do a dance into a method. Let's just leave it there for now, though. We'll do that next week. So look around does not work because it uses the old player position value. Right, we're gonna make a new one here. We're gonna use the player dot position now. We don't have a player position key in the game state anymore. Now the game state simply holds the player, and the player has a position. Okay. Again, we don't have a player inventory value either, or excuse me, a key in that dictionary. Instead, we're going to be using the player key to get the player out of it and then check its inventory. Likewise here, there is no player position key anymore in that dictionary. There's only a player key, and the player itself has an inventory. Oh, excuse me, a position. Okay, again, the torch is not inside this player inventory key anymore. Now it's in the player objects inventory. Okay, one more here. There's no position for the player that way. Now the player's position is saved here instead. Okay, right here, inventory. We're actually saving the inventory right here now. Awesome. Okay, get the key. That should work fine. Leave the cave. We can actually fix that right now. You can't leave the cave in this game until you get the key. We're actually going to change that like this. Awesome. Get the torch should work now. We already fixed that. Get the record. Okay. So we're actually going to change this to work with the new style of inventory. Likewise, right here, use the player.inventory, not this list that does not exist anymore. Okay, listen to the record, huh? So we have to use the new inventory method here. And now our code should be fully, let's do a really quick test of it, guys, to make sure it's fully working, that is. And then play some Mario 64, shall we? Okay, I think everything's working now. Let's, we changed all of our old code to the new code. We have a lot of changes to make next week for sure, though. What do you want to do? Let's look around, see if that works. Okay, it does work. Cave is dang, treasure chest. Let's try and leave the cave. Okay, we can't yet. We have no key yet. We can't leave till we get the key. Why don't we try and open the door? Let's try and open the door. Okay, it's locked. Try to enter the door. It's closed. Okay, why don't we try to get the key? Okay, we don't see the key. Let's open the chest. And now we see the key. Let's get the key. Okay, now we can leave the cave, right? Let's just do that. Leave the cave. Okay, game over. That's the one way you can win this game, by getting the key and leaving. All right, so let's try that again. Let's open the chest. Get the key. Unlock the door. Let's enter the door. The door's still closed. Let's open the door. Let's enter the door. Let's look around. It's too dark to see. Let's enter the door again. Get the torch. Go back to the door. Excuse me. Enter the door. Look around now. So now we can see we have the torch, right? Let's listen to the record. I don't have a record to play yet. Let's descend the staircase. Okay, look around. Okay, the basement's moldy. There's a shelf with a vinyl record. Now let's get the record from the shelf. Look around again. Okay, now the shelf is empty. Good. Let's ascend the staircase. Okay, let's listen to the music now. Okay, mellow music fills the room. Nice. Now we can enter the door and leave the cave. So our game is fully working again, guys. We improved it quite a bit. Although we spent so much time reviewing how the code was working already, we kind of didn't improve it as much as I would hope we could have. But next Friday, guys, we're actually going to make this game fully object-oriented, and that's going to allow us to add rooms quickly, add more chests, add more doors, add more items, add more, all kinds of cool stuff, man. It's going to be sick. These classes will allow us to manufacture objects very rapidly. So once we can make like this room idea be an object, maybe a room has a description, a room has an inventory, right? Like the first room has, you know, this chest and this torch and this door, right? And the second room has a door and a turntable and a staircase. And the basement has this shelf and this record, right? Once we can make these rooms into an object, into this idea of a room, instead of just being like a bunch of loose data, that's going to allow us to make new rooms very quickly, which will allow us to make our game much bigger, much faster. That's for next week, guys, next Friday. Guys, thank you for hanging out with me, by the way, for this Intro to Python stream. I had a lot of fun working with you guys here, making this game more cool, more flexible. If you guys enjoy Python and programming, want to help the channel out, financially speaking, Patreon's a huge way to do it. Patreon.com/Vencabot. Even $1 every month really helps me make the stream possible. And I stream for 40 hours a week, every week. And when the stream's over, I work on the stream all night long. The stream is my whole life here. And Patreon is what helps me buy gas and groceries and that kind of thing. I appreciate that very much, guys. Our Twitch subs, thank you guys for subscribing on Twitch. Patreon's a little bit better than that, but Twitch subs are still very much appreciated. If you're an Amazon Prime member and you have an Amazon Prime account, you can get a free sub every month. You have to renew it manually, though. It's kind of a drag. You have to remember to do that, but it's very much appreciated, guys. If you're like me, though, you're totally broke. Maybe you enjoy the stream a lot, you enjoy learning Python, you enjoy watching gameplay, but you can't really help out financially, right? No matter what you try to finagle. Help for free in that case. Get in the chat, come say hi. Follow on Twitch for free. Tell your friends we're here. and spread the word about the channel. We're doing all kinds of cool gameplay and educational streams, all kinds of cool stuff around here. We're also on YouTube at youtube.com/Vencabot Archive. That's youtube.com/Vencabot Archive. We have all kinds of cool Intro to Python streams archived there. Some more beginner type stuff, even more beginnerish than this stream is. This is our day 4. So by day 4, we're pretty advanced-ish. But our day 1 streams are much simpler. Also, we have gameplay streams, of course, archived there. Lots of long plays, retro games, modern games, horror games, indie games, AAA games, online stuff like Fortnite Battle Royale and MapleStory, as well as single-player content, of course. We'll go for a short break, guys. Come right back with some Super Mario 64. I guess kind of like a speed run. I'll see you guys very shortly with that. Until then, have a nice night. Have a nice weekend as well. Peace out. Peace out. So excited to play Mario, I can barely talk. See you around, Middle Storm. It's time for some Super Mario 64. I'm highest level now to fight the dog? Let's go. Yo, let's go. We can kill dogs now? I love killing dogs. Oh, you fuck! Jesus, that jump scared the fuck out of me. Dark Souls. Dark Souls. Look at this fucker. Dark Souls. Dark Souls. Dark Souls. Dark Souls. Dark Souls. You can't space them out, dude. Gotta play that footsies game with these guys. Gotta play footsies. Come here, fucker. Dark Souls. Oh, fuck. Dark Souls.